Nice. Okay. So primarily week 7, almost uh, about to wrap up our course, last 4 lectures or last 4 sessions. So today what we'll be discussing about IR systems, information retrieval systems. So typically anything that relates to like we fetching data using some information need. Like for example, search engine is a classic example of an IR system in which you are having a massive set of data, and then given a query, you are basically finding out a relevant result. You might see like even the select queries of a normal database might also fall into this, but typically that is what we actually know. So what makes IR systems different, or what makes our SQL database or our usual data stores not be called as IR system is because we typically know what we want. Like for example, we search for something, we give it an ID, it basically returns us the document, right? So we know the parameters that we need, and from that we basically filter out things on those ends. But with IR system, what happens is you have a good chunk of data set, and the way you are forming queries is not clear enough. So you just specify what you need. You don't specify how you need it. So you don't specify the relevance of it. So that's where IR systems comes into the picture, and they say, "Key, you just tell us what you need." For example, when you search on Google, you just specify, okay, I need this. So this is my search query, and basically Google finds you the best, most relevant document for you. So that's an example of an IR system. So what we'll be doing is we'll be building a very simple search engine. It's a text-based search engine. So no image, videos, any other format that will be supporting, pure text-based. But through this, what I would want to do is I want to scratch the surface about IR systems, build some mathematical logic around it, because whenever you are building any systems like this, a bit of math is obviously required when you're playing with data. Basic math is required, and so the basic math that runs or that powers a search engine, that is something that we'll be looking at here. So it will be loosely based on TF-IDF. For folks who know it, it will be a deep dive. For folks who don't know, we'll be like basically covering TF-IDF from scratch, and we'll be building the intuition for it. Right. So it's more about building that ability to think it through. Okay, if I'm actually given a problem statement like this, how do I even start? Right. So we'll be doing exactly that. So the idea is simple. What we need is like any search engine. It's as simple as like, we have an information need. Like I want something, like, and that information need is then being thrown into the search engine, and then search engine actually pulls out the most relevant uh, documents that would basically fulfill the information need. The collection of document is typically called as corpus or dataset. Basically, corpus is a more standard term, so you can call it a corpus dataset or anything. And the search query that we fire is nothing but our information need. So the things that you type on Google when you search it, that's your search query, which is nothing but our information need. So a document in a very simple sense looks typically like this. You have a document ID and a text. So think of it like document ID could be your document URL on the browser, right? So on that website, and the text would be the actual HTML content of it. You might choose to do some post processing on the data before you make it available for search and all, but that's irrelevant. So that could be part of like basic data processing, and then you put it into uh, your search engine. But the idea is simple. You need to have some sort of identification of the document and some sort of data on which you would be performing search. Right. So let's say our data set is this. You have document ID 1, and the string is Iron Man. Document ID 2, the string is the Incredible Hulk. 3, it's Iron Man 2. 4, Thor. 5, Captain America, the first Avenger. 6, Marvel's The Avengers. Okay. So given this 6 document, and this is nothing but our corpus. So our corpus has 6 files. See that. So our corpus has total 6 documents. Document ID is 1, 2, 3, 4, 5, 6, and these are the actual documents. Right. Now, what we want to do is let's build a very simple intuitive search. Like given a word, and let's say a person can just input one word. Right. So given a word, what we want to do is we want to find all the documents that would be relevant for that word. Right. So the most basic intuition here would be given a word, let me just find if that word is present in the document. If it is present, I would return it in the search result. And the order would be the first document I found is the first document which I return. So now what we can do is, let's say someone searched for word iron. It would go through it would start going through document from 1, 2, 3, 4, 5, 6. It would go through first document to find the word iron. Yes, iron is there. It would add it to the result set. It would go to document 2. Is iron there? No. Then third, is iron there? Yes. So it would add Iron Man, then Iron Man 2. We'll do this until we get that 10 results. For example, if our pagination is of 10, we get 10 results and then we return it. Right? So this is a normal linear search that we are doing onto this. So given this, this is a very basic intuitive search that we could build. Like given n documents in the corpus, the complexity is order n. But there is something even much more worse than that. Because now since it's not just like order n, but you are also doing a substring check. If the substring is present in that, and that is also expensive because substring check in worst case it's with the best algorithm order it's still order n. Now here n would be the average length of my document. So here the length of the document is very small. It's just like it's max like 32 characters. But if you see at the scale of Google or in general normal search that you might build, the document that you would be putting in would be big enough. It could go into like 5 kbs, 10 kbs, and doing a substring search on that. And if that is your average length, then the amount of time you would spend doing this is will become massive. So where your substring search itself would become expensive. So what would we do to make this thing better? Right. So this is a very classical problem, like similar to what we saw with databases. Like we saw linear search. When we did linear search, we know that this doesn't work. So then what do we do to optimize it? We create indexes out of it. Okay. How would we index data in this case? How would we do that?
Every word will have in the list of document IDs, which I mean it's like a trie basically, which will have the document IDs. And whenever you want to search for a word, you get the basically once you traverse the trie, you'll be able to get the list of documents.
So you are storing all the words in a trie, and then on the trie, at the end of it, you would have a list of documents.
Yeah.
Okay, a list of document IDs to fetch from. Okay, that works well. But if to at first, let's remove the complexity of having a trie. So it could be as simple as an index like this, where what do we have? We have all the possible words like Iron Man, the Incredible, Avenger. So each unique word in my corpus, and against that, I would store the document IDs in which it is present. Like, so basically what we are doing is we're creating an index out of it. This index is called as inverted index. So it stores that the word iron is present in document 1 and document 3. The word the is present in document 2, 5, and 6. Right. So this is what is called as an inverted index. An inverted index is the core data structure that is used in any IR system, because inverted index makes things lightning fast. So iron is the key, and the value is like 1 and 3. Man is in documents 1 and 3. The is in documents 2, 5, 6, and so on and so forth. Now, if someone searches for iron, instead of doing a linear scan, the person only has to look up iron in this inverted index. If it is present in the inverted index, then we get the corresponding list of documents in which the word would be present, and we just return it. Here we are assuming that a search query is just one word, right? We are not adding complexities of having multiple words. Okay. So one word, we immediately get the response. So our complexity is almost order one, Okay. Now, how do we do an efficient lookup or inverted index for that word? Like we can't do binary search on strings. That would be really expensive. So what Varun suggested is exactly how it's done. So you would have a trie sort of structure in which you would be using it to, to very quickly go to this particular part. Like for example, if I want to search for the string iron or the word iron and find out the document list, So how would I do a search? How would I do an efficient search on these words? Right. So for doing an efficient search on these words, the data structure that we can leverage here would be try, in which the way we would be storing it would be a base word, then IRON, and then you would have this list where the document ID 1 and 3 is written. Then you might have M, A, and N. Then incredible, so MAN mein aega 1 and 3. So this way, our search in this inverted dictionary itself becomes really fast. Like the way we would be spotting the word and then getting the posting list. So the list of document IDs in which the word is present is called as posting list. Okay. So we typically address the problem of having like one word. If it is present, we would be immediately searching for it, and we would be returning the document IDs or the documents in which the word is present. So this makes our things really fast. Right now, now what do we do? So now let's add new thing to it. So our lookups are fast because if it was one word, our lookup is fast. So for any given word, we get the posting list and we immediately return. Right, order one lookup complexity. So average of order of length complexity, but it's still very fast in case of try. And then we get the posting list and we immediately return. Right. Now let's add complexity. What would we do when we have multiple words? What if someone searches for iron incredible or iron man? How would we handle that?
Search for both and merge.
You do intersection?
Yeah.
Okay. Chalo. So let's do this. So if you do intersection, let's take an example over here. Let's say my word is iron incredible. What would your search result or
Why
what would your
not to
search result
use
be there?
why not to use this map kind of a structure for indexing?
You can do that, but how will you do string search on map? You can still do it, hash based searches
Key,
and all.
yeah, key will be, yeah.
Yeah, you can
String.
do that. There are, see, you can use any data structure you want. Try is the most common way to implement.
No, try basically the problem is like when you want to do the horizontal partitioning and all, right? Hash is very natural way to do
Yeah,
that.
yeah, yeah. Yeah, yeah. No one's pointing us. So things differ at scale.
Yeah,
The way you might start is different. The
yeah,
way you'd scale is different. Your point is great because when you would want to partition it, because you have leverage, you can leverage distributed hash tables to split. If your corpus is that big and you would want
yeah,
to split it across nodes, then you can use distributed hash tables, and for that basically maps work really well. Try is very solid case where you just have one server in which everything could be fit in. That
yeah.
would make it very faster.
Otherwise, the horizontal scaling you have to track when
Yes.
some words and all.
Some words here, some words there. Agree. Okay. Now, when you have two words, what would you do? If you have words like, or let's say if someone in on this data set, if someone searched for iron incredible. So Varun recommended we do intersection. So we first get iron. Iron pay we get from the posting list, we get 1,3. And from incredible, we get 2. So our intersection would become null. So we
Zero.
are
Yeah.
saying no results found.
Yeah, sort of. I mean, intersection is the best way, but the best, if there are no results, maybe we can do an union.
Correct. Correct. So now what should we do is when we are building an intuition like this, instead of taking a binary approach, like only intersection or only union, because if you do only union, you might not get best result. If you do only intersection, you might get a lot of no, you might get a lot of no results. So what would happen is in that case, your user experience in both cases would become terrible. So the idea is very simple. Go for both. So when you're building something like this, you should always go for, because you know that the documents that would contain both the terms would be the most relevant documents. So you might do an intersection first, and if this results in no result, then you might do union, right? And usme bhi you might find ki you might want to order it in terms of like number of words that are there in the document. Like for example, if the search query is of 3 words, like let's say if I'm doing a search query. So this is something that I did with in production when we're using Elasticsearch, when I was building search for an academy. This is exactly what I did. So we have multi-tiered search. So the first tier is where we do intersection. So given all the words in my search query, I would fire it onto my search engine, get all the documents, get the documents in which all the words are present. Right. If that is not the case, then I do this thing. So first, let's say I have query like A, B, C, and D. Okay. So these are like my single search query having 4 terms. So a good way to do it is first start with intersection. So find documents that contains 4 words. Matlab all the 4 words like A, B, C, and D. This would be the top ranked documents. Then you move to the 3 words. So out of the 4 words that are there in the search query, find the documents in which there are at least 3 words out, or in which exactly 3 words are there, right? And then 2 words, and then 1 word. So this way, this is still an intuition. This is not the best algorithm out there, but this gives us, or this way, we are trying to form an intuition out of it and see how we can deal with this. Okay. So instead of just picking one over other, you should be doing a multi-tiered approach with search. So start with intersection of all the documents that contains all the words, and then do union such that like the higher ranked result would be the one in which more terms from the search queries match the documents. And this way, you minimize no results are found. Like for example, if someone does a typo, right, or someone gives out a word which does not exist in your vocabulary. Let's say if someone gave out a word like Hawkeye, but Hawkeye does not exist in the system. Let's say someone give out Iron Hawkeye or Iron Man Hawkeye, right? So, but if Hawkeye does not exist, you would use it as an empty thing because like there are no documents that match that. So at the end, you are sending out result having no, you are sending out results saying that there are no results found for this. But instead, there are documents that contains Iron Man. Even if there is no, even if there is no Hawkeye in your corpus, but you are still serving results for Iron Man, which makes sense, right? So you would always want to have a tiered approach whenever you are approaching a problem of information retrieval. Always apply that. This works in most cases out there. So whenever you're building a system like this, see if you can leverage this. And here, there are other ways to do it. Like for example, there are different strategies to do it. One of them is a Boolean expression based strategy, right? So where and basically this is very similar to that, where you would find the documents which contains A and B and C and D is one that you're returning, and then you'll find documents which contain A, B, and C but not D, B, C, and D but not A, and so on and so forth. Like so, you might do something similar to that. So these are like Boolean expression based search engine. What we'll be looking at TF-IDF based search engine. We'll be coming to that. Let me just take a question. Yeah, Piyush.
Yeah, so for 4 words, there would be 2 cases, right? When 4 words are occurring simultaneously, right, one after the other. But there might be cases where they are not simultaneous; they are splitted across the document.
हाँ तो वैसे ही करेंगे ना, because what we'll be doing is we'll be not doing that entire thing का substring check. We'll be using posting list to do that. Now we'll find posting list of A, posting list of B, posting list of C, posting list of D. Then once you get the posting list, then what you would do? Right.
Okay.
वहाँ पे you'll find the documents in which all the 4 words are present. Then you'll find the documents जिसमें at least जिसमें 3 out of those 4 words are present.
And then but there might be some documents in which Iron Man, like both of these words are present, right, one after the other. So those would be
वो proximity आ
prioritized.
गया, वो थोड़ा advanced है, थोड़ा सा
अच्छा,
advanced है. Where you are actually considering the proximity. Where so basically what is suggested here is, what if you want to take into account the proximity of the search term. Like for example, documents in which let's say I've searched for Iron Man. So the documents in which Iron Man is close enough should be ranked higher versus the document in which Iron and Man are present. So let's say an article about Iron let's say a document that tells a story uh, about a person who wields iron and builds swords out of it. So you might find a word man in it, you might find the word iron in it. But this does not mean that article or that word is up or that document is about Iron Man. So you might want to rank the documents in which Iron Man is closer. So Iron and Man are closer versus father. So these is like once you have identified a candidate list, then how do you rank it? Right. So Abhi, here what we are doing is basically first come first serve. The first document that matches would be ranked higher. And but obviously there are hundreds of ways to like optimize the results. We'll be talking about that a little later. कि क्या क्या कर
We are
सकते
just
हैं.
trying to fetch all the documents जो match
We're
कर
just trying to fetch all the documents.
ठीक है.
Now, once we got a lot of documents, then comes the part of relevance, right? So which one of these are relevant enough? Like something similar to what we were discussing right now. Just having iron and a man in one document does not qualify it to be surfaced on top. Well, if there is a document called Iron Man in it, because the document that has Iron Man together would be a very relevant document as compared to the other one, right? So these are a lot of intuitions are used to build search engines. It's not so basically building search engines is a massively complicated problem because it's like building something that would quench the thirst of the basically that would satisfy the needs of all possible users of your system, which is incredibly difficult because you don't know what they are actually looking for. Like because not everyone is skilled at basically communicating what they actually need, right? So it becomes really hard to solve it at scale. So when we define relevance, so what we would definitely want is up till now, up till at this stage, we sort of build a search engine, but it's like just building or just finding out documents that meet our criteria, right? We never talked about ordering it. Somewhere like pehle 4 words match, then 3 words match, then 2 words match. But what if there are collisions there? But what if there are but what if there are 5 documents in which all 4 words are present? Now, how would you rank within them? That's where relevance comes into the picture. So you'd say that results are relevant only when it matches users' expectations. And this is easy to write, but really, really hard to implement. Like there is a good way to quantify this, right? And this makes problem interesting and fun at the same. It makes the problem really tough and real fun at the same time. So the idea is like what we do is we build an intuition which document would be relevant given the query and the corpus, which document would be relevant to the user. So the problem statement is like given a list of search results, like what we got, like given the list of all the candidate results that we have for a given query, we assign a relevance score to the document. And this relevance score should maximize the satisfaction of the user. Like the user should say, okay, basically this is exactly what I was looking for, and the user should be happy at the end of it, right? What is your intuition to do this? How would you build it? Let's brainstorm thoda sa. What's your intuition? Like what would you say that or basically when would you say that a document is relevant for a search query?
It's in the same order which we searched. It will be more relevant.
So A, B, C, D pay in the same order. If I get, it's more relevant. Is it?
Based on the click history of all the users? I mean, eventually.
Direct ML पे हाँ ठीक है. History of all the users. But पहले यार मतलब पहले basic तो बना देंगे but ठीक है. Then we'll look into history. But what if the user is new? What would be the first thing that you would show the result? And by the way, the worst part of being a user or while working with search, what I faced was no matter how shitty your search results are, the user will always click on the top 3 results, and which would eventually make a system worse. That's what I've seen in production. Like I was for a week or so, our search engine was broken and we didn't even know that. But still there was no impact on CTR. No impact on CTR whatsoever because users are habituated to click on the first 3 results that they get. So that happens. So You'd always need to ensure this part ki matlab users are always served the best thing out there. Yeah.
So what is CTR?
CTR is click-through rate. So user seeing that result and then clicking on it.
Okay.
So this is one of the core metrics that is tracked by any search team out there. And they track that on an average, what position of your result gets clicked the most. If your search engine is very good, people will most likely click on top 2, top 3 results. Right. And if your results are not relevant, people would have to scroll and then they get that thing. Okay, their result was found on page 2nd of Google. Let's say it was on the 15th position. So that would be a negative feedback to your system. Yeah, this result is relevant, but it's surfaced on the 15th position. Right. So when people are going there on the 15th position and clicking it, this is a negative feedback that you get for the search engine. And then you basically promote that result on your search engine.
But then it can affect, right? I mean, if somebody
Exactly.
wants,
You don't have to do it like if just one user goes on the second page and clicks on the 15th result, it doesn't mean that you have to promote it at the first. There are lots of weights that goes in, and if the document is really relevant, there are at least 2,000 to 3,000 features that are being considered before they surface you these results. So
yeah,
just for a very small search engine that I have built, we considered 86 features. So बाकी तो Google का तो सोच ही लो.
yeah.
The
But what's your
popularity of the
intuition?
page.
What would make a result relevant to a user?
Popularity of the page itself.
Popularity of the page. But how would you quantify popularity of a page?
Like links referring to that page.
Okay, so this is more like page rank. So what is recommended is links if there are this is the exact intuition behind Google's algorithm. So Google's first algorithm, it's called page rank, in which what they say is if one of the document or rather if one of the website is having a lot of or if let's say if basically one of the website is popular and if that website has your link, which means your link has to be good. Right. This is a very simple intuition on which the entire Google was established. So this algorithm is called PageRank. If you have not heard of it, go and read that paper. It's a very simple read. It was the most revolutionary algorithm out there at that time. Please referring to it. But here, what we are talking about, we are talking about a very limited scope of the document. Let's say we are just building a search on top of IMDb database, or a very simple domain specific search is what we are building. So PageRank is typically used when you're building search engine for the internet, right? Because in local corpus, you might not even have cross links to other documents, right? So think that as well as a constraint, and then build some.
It could be like how many words are present in the document, the frequency of the word when you are searching.
Frequency of the word. How would you exploit that?
Let's assume I'm searching Iron Man. I'm getting 5 documents. There is one document where Iron Man has been used multiple times, like 8 to 10 times, and there are other articles where probably 2 or 3 times. So more often than not, this is something meant for Iron Man subject.
Okay. So if word is used more, then the document is relevant. That's one intuition that we set up. Because like on some document, if let's say Iron Man is just present once, versus in one document where Iron Man is present, let's say 1,000 times.
Yes.
Right. So in that case, that document would be more relevant because the document which is actually talking about Iron Man, let's say we build a search engine on top of Wikipedia, and the document in which the document which is the Wikipedia page of Iron Man would have a lot of references to the word Iron Man. So through this, what would happen is that document will have a lot of references to Iron Man. So that should be more relevant when my query is about Iron Man, right? So that's a first intuition that we set up. Like any other, what could go wrong with this?
Yeah, user or the author can, I mean, not have good content, but just have the words. so that
Exactly.
it,
Right.
it
So
gets
let's
ranked
say
better.
a lot of people are searching for Iron Man. The document is about, so let's say the document is about a cooking recipe, but that author put in a lot of words like Iron Man, Iron Man, Iron Man at the end, let's say a million times. So automatically for Iron Man, this page of cooking would shoot up. By the way, this is exactly what people used to do when they found out about Google's algorithm. So one very interesting story. People used to in those good old days, almost all the websites had this white background. So what website authors did were they wrote the text in white background, and they used to basically put it there. So at that time, CSS hidden property was not there, right? So they used to just add these keywords, and the text color used to be same as the website's background color. Obviously, Google would not find it because Google is just using like the HTML content of the page, and it used to like rank those results up. So this was a very famous trick which people applied during the initial days of search engines. Then when the hidden property of CSS came into the picture as a full-fledged thing, people started adding keywords, and then they basically hide it from the view of the user. But anyway, when Google used to like scrape the HTML data and parse it, the Google used to see these keywords, and it used to rank the results. Okay, that's another con. How can we address this problem?
Then it could be like the first concept would come into picture if many people are regarding such articles and come to conclusion there is something wrong with this one and we shouldn't be showing it because they're doing deliberately to sort of to uh, yeah, having a bias towards a particular that we can do if many people are sort of complaining about it's not relevant.
But you are waiting till users would complain, right? So that is one good way to do it. So that's why Google still has this button called report. So when you do that, you can report, okay, this result is not relevant, and Google actually takes it as a negative feedback and then basically loops it into the system, right? So in most cases, to identify such random pages showing up on top of the results, the best way to do it is let your users give you the feedback. This is not relevant. Most of the search engines actually do that, either implicitly or explicitly. So either they would judge it by your action, or they would ask you to rate the quality of search results and all. The problem here at hand is like this is okay that one document having multiple occurrences of the word is relevant. And if one person has added, like, let's say, what if someone adds that Iron Man, although all documents are about Iron Man, but let's say Iron Man is added a lot of times in all the documents. Would that word be important enough? If a word is present in a lot of documents, do you think that word would be important enough? Let's say the, right? So just like Iron Man, the word the is something that would be present in almost all the documents, and that too a lot of times. Right. So now what would you do in that case? Would still want to like give that word a massive boost? Because like that's not adding a lot of value to it, right? Yes, Anand?
Yeah, yeah. So we need to sort of figure out like these words, like as you mentioned, common words. One is the, one is a or an you are using. So those things we can take into account when we are coming up with this thing, because obviously almost every English sentence would have this
Yeah.
sort of word.
So such common words are called stop words.
Yeah.
Right. So these stop words are something that you typically eliminate out. So depending on the corpus at hand, you would be removing the stop words from it. Right. So is, am, are, was, were, has, have, had, do, does, did, shall, should, will, would, can, could, all of such words. These are like really common words. And you typically do not index these words in your search engine. But obviously there are exceptions. Let's say if I search for only the, I would still need to get the results, right? So there are ways to handle it, but obviously you need to be wary of the fact that these words do not add a lot of information value to your system, right? So you can remove these words out of it, out of index again. Okay. Or another way to do it is similar to what we did with tiered approach. You would first do a search without stop words and then a search with stop words. Because if you don't find good results without stop words, then you would add the stop words and then do the result. Let's say if someone searched only for the. Now, what would you do? Like if you remove stop words and you're not indexing it, then the pe to no result aa gaya, which is not good. So what would you do is you'd first try to make a search without the, and then if you don't get any result, you'll make a search with the, right? So basically that's why multi-tiering approach comes in very handy. Now, what's other interesting? So stop words is okay. Stop words, so stop words, these are like very common words out there, right? But what else? Could there be any other stop word apart from the common words there? Can stop words be domain specific? I'll give you an example. Let's say I have a Wikipedia of only Harry Potter. Only Harry Potter. Then the word Harry. So since it's a very domain specific search, right? So the word Harry would be present in all the documents out there. Is the word Harry adding value to it? Right. So it might not be that. So what you would typically do whenever you are building an information retrieval system, what you are doing is you are improving on relevance. So you would be putting up the documents in your search result that gives you nice information about the search query, right? So is having a word like Harry in a document corpus which is very restricted to Harry Potter, the word Harry might not be adding that critical of an information, right? Because if you add Harry, then almost all document has it. So typically what you would want to do is you would want to suppress the importance of the word which are common across the corpus. So this would include stop words like is, am, are, was, were, as, have, had, vale words, and any word that is present in a lot of documents, which is definitely not adding enough value. So if word is common, then suppress. We are not removing it, we are just suppressing it. Okay, this is very important. So stop words is typically when we when we remove it out of indexing, but here we are just suppressing the importance. So this is what our intuition is, right? So most of the systems in data science, information retrieval, whenever you are playing with bulky data, it's mostly built around intuition out of this. Yeah, Varun?
You said you won't index the stopwatch, and you said that you'll search with and without.
Yeah. So
That's
so multiple ways to implement it. So these are always configurable, right? So you may choose to like not, so depending on the system at hand, you may choose to like not even search with stop words on. But if you are operating at scale as Google, you would want to have stop words also indexed, right? But I'll basically take my words back. I'll still index stop words and have a multi-tiered approach. That's the final approach that we'll go with. But all the literature that you'll find on the internet, they would say remove those stop words. So that's why I was just trying to, basically put forth both the approaches. So a good approach would always be a tiered approach where you would first search without stop words, and secondly, you'd search with stop words. But if you index stop words, then your index size would grow very big, right? Because the stop word would be almost would be present in almost all the documents. So the posting list against it would be very big. That's the problem. So that would make your index size grow massive. So that's why a lot of search engines do not even index the stop words. Right. So there would be like some documents, let's say for a word which is extremely common, let's say which is extremely common, instead of indexing or instead of finding all the documents in which the is present, instead of storing all the documents in which the is present, you just store like top 1000 documents in which the is present. So these are called champion list. So you are giving a preferential treatment to stop words. So there are there are hundreds of ways to handle it, and I can like talk about it, but it might be a little complicated. आखिरी में लेते हैं इस पे, we can do a very deep dive on that. How we have handled stopwords. So this was something that I also did as my master research. So stopwords पर बड़ा खेला है मैंने तभी. So we can definitely talk about it. Okay.
But then in the multi-tiered approach, the response would be not slow. I mean,
it would be slow, but obviously, but the first pay, if you get the result, you would immediately send now. But if you're not getting result, then only you're going to the second tier.
oh, okay. Then if the further user goes down,
मतलब अगर पहले पे if the user did not get any result, let's say you are searching, let's say your search query is only let's say only the is a stop word, right? So if the is a stop word and your query is just you would make first search as without stop word, right? You would not find any queries, or you would not find any document out there having it, because that's what the search criteria was, that you would want to eliminate stop words. But then since you found no results, then you would do another search with stop words.
got it. Yeah.
Right? So the intuition that we formed till now is like our relevance score is directly proportional to the number of times the term is seen in the document. Right. So a word is present more in the if a word is present more in a document. Just finding who's other word. Yeah. So the idea is simple. So our relevance document, our relevance score is like directly proportional to the number of times the term is seen in the document. So this would help us give a boost. Let's say if I'm searching for the word Sachin, and this would give a boost to a document which is Wikipedia page of Sachin, in which Sachin would be present like basically thousands of times, right? So our document is relevant. So the idea is simple. So document is relevant for a search query if the search query is present in the document a lot of times. Correct. So Sachin in Sachin's wiki page, Harry in Harry Potter's wiki page, these would be like those corresponding pages should be ranked higher, right? But if the term is too common across the corpus, downplay its weight. So the A and is R, downplay its weight. So typically what we're doing is our score is directly proportional to the term frequency. So the number of times the term T is present in a document D. It's not present along the corpus. Here we are just considering the number of times the term T is present in a document is what is called as term frequency. So our score would be proportional to this. And our score would be inversely proportional to the document frequency. So the document frequency is the number of documents in which the term is present. Is basically the number of unique documents in which the term is just present. Let's say if I have 100 documents, if then the word the is present in all 100 of it, my document frequency for the would be 100. Right? It would not count the summation of all the times the word the is present. No, it's just the count of number of times or the number of documents in which the is present. So we have term frequency and then we have document frequency. So TF and IDF. So this is inverse document frequency. And that's why the formula, and basically that's why the algorithm is called as TF IDF, because the score is nothing but the product of TF and IDF. That's why it's called as TF IDF. So hence the scoring function is called TF IDF. So our scoring function, just watch this carefully. Our scoring function is for a document and a term. So for a given search query, or let's say for a given search query, let's say search query is of just one word. Okay, just one word, which is T, one term. So given one word, what is the relevance of my search query to a document? So how relevant is my document, or how relevant is document D for term T, is given by the product of term frequency, which is TF of, so how many times the term T is present in the document, multiplied by log is something that will come to multiplied by n divided by document frequency. So document frequency is the number of different documents in which the word is present, right? So we are basically positively amplifying the document that has the multiple occurrences of that word, and we are downplaying on the part that if the word is common, I want to downplay the score, right? And here, instead of doing just by 1 by df, it is doing n by df and applying a log on it, so that it's a logarithmically decreasing function. We'll come to it, like what's the significance of it. Let's just take one short example for this. So what I did was I built a search engine on top of Harry Potter's Wikipedia. So I take a subset of Harry Potter's Wikipedia pages and I just built a small search engine on top of it in Python. You can find it. You can find the code in my GitHub repository. So I published it like HR something something. I have. I'll just put the link of it. It's called HPSC or something, Harry Potter search engine. So I built it, and while I was doing that, what did I do is just to like get a deeper understanding of it. So what I do was I was just looking for the word Harry and I was seeing how the TF-IDF is working. So the document ID for Harry was 13, the term frequency of Harry. So in the Harry Potter's Wikipedia page, like that's a Harry Potter's Wikipedia page. For that, in that page, the term Harry was present 2,188 times. But since the subset that I was working with was only about Harry Potter, so Harry was present in virtually all the documents. So Harry Potter was present in 940 documents out of 1,000. So I took a subset of it. I had just 1,000 documents. So out of those 1,000 documents, 940 documents contained the term Harry. So this gives Harry Potter's wiki page a score of 135. Right. And now this is my relevance score for the term Harry for the document 13. This is something that I would do for all the documents in my candidate list. So let's say all the document that contains Harry, I would be computing a score like this. And then I'll score those, and then I'll sort the documents in the descending order of this score. Through this, what I'll get is the one with the maximum score would be possibly the most theoretically would be the most relevant document according to this formula. Right. This is the idea behind TF-IDF. Another example, if I take the term Slytherin, and now the document ID 13 was for Harry Potter's wiki page. So when I search for Slytherin in Harry Potter's wiki page, what I get is it was present. The term Slytherin was present only 75 times. Right. In Harry Potter's page, the term Harry was present 2,188 times, but the term Slytherin was present only 75 times. But the term Slytherin across 1,000 documents, were present only 423 times. This gives it overall score of 64. So Slytherin for Harry Potter's Wikipedia page. So basically Harry Potter's main Wikipedia page, how relevant it is for the search query Slytherin, it's just 64. If I take another example of, let's say, Slytherin document for Slytherin's Wikipedia page, right? So that term is present. So Slytherin in Slytherin's Wikipedia page is present 191 times. Now this score, if I compute this is 164. So Slytherin's Wikipedia page for Slytherin query gets a score of 164, but Harry Potter's Wikipedia page for the term Slytherin gets a 64 score. Now you can see automatically my Slytherin page, when I sort the documents in the descending order of this, my document of Slytherin, Wikipedia page of Slytherin would automatically shoot up. Right. So our intuition, the way we have formed the formula, seems to be working fine. Right. Any question at this point? Nice. Okay. This is a very core understanding of it. Although it looks like a lot of math, but as you would grow and solve tougher problems, math would become inevitable. So you have to like stick with that. Yeah. So now comes an interesting one. So this is what the formula is. So score of this for a t is equal to term frequency multiplied by log of this thing. Now when will a document D get a high score? The document D will get a high score for a term T when my term frequency is high and my document frequency is low. This would make the document heavily relevant for the search query. Right. An example of this is, let's say I'm talking about a page about let's say Quidditch. Okay. the page about Quidditch, which is a sport in Harry Potter, the word Quidditch might be just present in like 10 or 15 documents. Right. So those documents, and in the Quidditch wiki and in the Quidditch page, it would be ranked very heavily. It would be present a lot of times. Right. So those 15 pages the way we would be ranking is how relevant would be that. So when my term frequency would be very high, then my document frequency would be very low, which means I'd be converging on the small set of documents in which the word is present, that would be the most informative. So basically this is like the most informative document about the term, right? So if the term frequency is very high and the document frequency is low, this would make the document heavily relevant, right? One very interesting ploy that would happen is, what would happen when my term frequency is high and document frequency is also high? What would happen then? Given this formula, what would happen when my term frequency is high and document frequency is high?
It will be average.
Will it be? Sure.
And logarithm will definitely exponentially decrease it. So it will be 1 basically. DF
Correct.
log 1 is 0.
Correct.
So TF will be small.
No,
the
TF will
score
have
be small.
log 1 is 0. So TF
Yeah.
into 0 would be 0. So what would happen here is, if a word is present in all the documents, right? So if my word is present in all the documents, let's say there are n documents, and if my word is present in all the n documents, n upon n is 1. Log of 1 is 0. TF multiplied by 0 is 0. So for the words that are present in all the documents, my relevance score will come out to be 0. Right? So it is basically trying to punish the words that are present in all the documents, because it does not give out any information out there. It does not provide any good information in support of my query. Right? So this is what the beauty of TF-IDF is. Like, it's just one very elegant mathematical function, but it so beautifully handles all the cases. Like, if my word is relevant, if my word is not relevant, and it's built out of intuition. That's the best part of it. Yeah, Amrish?
So log 1, it's like it's present in all documents. It means it's a resemble. It's present in all. So it's not giving preference to this document, right? All are more likely same.
Exactly. All the documents are same.
But the frequency by which it's present doesn't have any meaning, right? Then
yeah. So these are special cases. You cannot have one formula that would cover all possible cases. So these covers 80% of the cases. The kind of cases that you're talking about is, let's say, once you get the relevance score, and if the relevance score are same, then you might apply secondary sorting technique, which could be like raw term frequency. Correct. So obviously this is not just one score through which you can do. So obviously when the relevance score is same for two documents for a given query, that's a tie-breaking situation. You can have any tie-breaking algorithm there. You would say that, okay, the document having higher occurrence of the term would be ranked higher. Right? You would always need to have a plan B. So what if this has a collision? You would have another tie-breaking factor then. Right? So ये भी multi-tier हो जाएगा वहाँ पे. ठीक है? Now, one very interesting drill that we can do is, how do we find out stop words out of data set? Given everything that we discussed about, there are some generic stop words like ismr, was, were, though, and all. Like, but the way we saw, like, some words are stop words with respect to the domain that they are operating. Right? If you were to find out stop words from a data set, how would you do that?
Whose resemblance is same, right? I mean, relevance is same. It means it's present in all over.
But relevance with what? See, the input to you is one data set. You don't have a query whatsoever, right? You'd want to find out stop words from the data set. The input is just the data set that you have. That's it.
One way is to, you have predefined set somewhere, already listed that these are the stop words I will ignore.
We don't have that. We have to identify. We have to create our own list of stop words.
So otherwise, just the calculation we did, right? If it's present in all the documents, then we ignore it.
So here it's not about ignoring, it's just about we building the list of stop words that we have.
Then maintain, then put into the stop words if it's present in all the documents. And it's
what if there is no word which is present in all the documents?
Okay, so maybe some some 70% probability or something like that is present.
But you might then just miss out on the words that actually gives too good information. For example, Harry, as the word Harry, right? Example, right? Harry out of 1000 document is present in 940 document. More than 75%.
Right.
Harry ko stop word bol doge.
Yeah, okay.
Right. This is where like this problem statement becomes really interesting. What would you do? In general, how would you guys do it? Let's brainstorm. बहुत simple solution है, but let's brainstorm. मजा आएगा. बताओ? अरे करो. Sub. And by the way, we have discussed everything that we need to find out this. There is nothing new to offer here. It's just about applying what we have learned.
When we try to build the inverted index, the size of the posting list is almost equal to the number of words, number of documents.
Yeah.
So when we build out the inverted index, we'll start to, as we're filling out that posting index, that posting list, we'll see which word is more common than others, relative to others.
But then how will you identify that these exactly are the stop words? Like, because let's say there is no word which is present in all the documents. Like I just give you an example. Harry. Harry is present in 940 out of 1000 documents. Would you mark it as a stop word?
Words for which TF and DF is high, like sort in descending order, and then make a decision.
Exactly. Not just judging on the document frequency, right? So, but a slight variation. You can also consider the term frequency, because the true stop words are the words that are not only present in all the documents, but they are heavily present in even. So they have a very high TF as well as DF. Got it? So so for example, the word Harry is present in a lot of documents, right? But it is not very heavily present in all the documents. Right? Matlab, the term frequency of Harry, let's say the term frequency of the rather the average term frequency of the in my corpus, right? If it is very high, then it is definitely a stop word. Right? So it has to be the combination of term frequency and document frequency. Don't just consider document frequency as the criteria. Right? So what a very simple, a very intuitive approach to do this is,
so basically TF is also there associated, and number of documents that TF should be high.
So TF is also high and DF is also high. That would make it a stop word. So when TF, so when average, just right. So basically the idea is when average term frequency is high and document frequency is high, this would make a word a stop word. Right? Because basically term frequency is a frequency of a term in a document. So you take an average term frequency, right? And see what's the average term frequency. If that frequency is also high and document frequency is also high, then that word becomes a stop word. So यहाँ पे is, MR, was, were would become a stop word, because in the average term frequency of these words would be very high and the document frequency is also very high. Yeah. Another way to approach this is like use all the words of your corpus as a search term and find out the TF-IDF score for it for all the documents, and then apply some combination of it and see which one has the lowest TF-IDF score, and then mark them as a stop words. So using the words of your corpus as a search term on it, and then finding out TF-IDF, and then basically finding the document, or then basically finding the lowest TF-IDF score would also work. But the intuition would still be this only. Same ही हो जाएगा in that case. Clear? समझा? Because this is what would distinguish Harry and the. Because Harry might not have a very high very high average term frequency versus the. Yes, no, नहीं समझा.
Yeah, right, correct.
Right. So ये सारी चीजें, all of this thing is all about intuition. Like one intuition, and like you would have a solution for that. मतलब most of the fields of data science, information retrieval, whenever you are playing with such ambiguous situation, it's always the intuition at play. Right? Always think about it. Always have your critical thinking cap on. Right? Life would be very simple. Okay. Now, although we have discussed this, but just to iterate it once again, TF-IDF is very heavily used across all the search engines out there, but it is not a great solution, but it works very well. On a generic use case, it works wonderfully well. But there is very easy way to abuse it. How can you abuse TF-IDF? Something that we discussed. So how can you abuse TF-IDF given this formula? Is when you have a very high term frequency, that's when you can abuse TF-IDF. Correct? So something that we discussed at the first, where let's say someone just added Iron Man 100,000 times in the document. Now, even though that word is too common across it, but if this grows very big, right? So ये log अगर छोटा भी हो गया, if it approaches 0, let's say if this log key value comes out to be 0.001, right? But if my term frequency is in millions, my overall relevance score would become higher. Correct. So if my term frequency is very high, I can very easily abuse TF-IDF, right? Because term frequency is what is in my hand. Document frequency is not in my hand. Correct, because document frequency is like number of documents in which the word is present. That is not in my hand. That is not in my control. So if I would want to abuse TF-IDF, what I would do is I would just add the terms that I would want to be ranked for a lot of times on my web page or on the document that I have. And through that, I'll get a very high relevance score for that. Correct? So if I'd want to search, if I'd want to theoretically rank first for all possible search queries that could fire on my search engine, what should I do? I should add all the words that are present, all the possible words in my document 100,000 times. So for any search query that gets fired, my document would come into the candidate list, would have a very high term frequency. So my overall TF-IDF score would be higher. Right. So this is very easy to abuse TF-IDF. Now, how will you prevent such situations from happening? What would you do to prevent such situations from happening? How will you find out such documents which are abusing TF-IDF? It's simple. Yeah, go on. Please, Bhupen.
Maybe like the order of difference between TF and DF. Like you said, the TF is millions and DF is very
Loved
rare.
Loved it. So understanding the pattern between TF and DF. See, in most cases, it's all about playing this. It's all about intuition. So if someone is trying to abuse TF-IDF, then your intuition would say that, if my variation, so if someone is trying to get the document up, then it would have a very high term frequency. So if a word is present, if any word, so if you do a normal histogram analysis, or if you do a normal word count analysis of a document and you found one of the word being abnormally high in the document, then the document is abusive. So you can basically downrank the results. This is exactly what Google did. Like at that time, it was a very quick hack which we applied. I think it was Larry who told in one of the interviews. It's a very old interview that he gave on YouTube somewhere else. I watched it like 2015 May. And basically, this is exactly how they solved the problem. They just did so whenever they used to see a new document being indexed, they used to do a normal histogram analysis of it, and they used to find out if they see any abnormality in the word distribution of it. If they see it, if they find it to be anomalous, they used to downgrade the results, or basically downgrade the document in the results. As simple as that. It's all intuition. It's all intuition, right? But हाँ, मजा आता है. So one very interesting thing is like although we looked at TF-IDF as a formula and people use it as a blank slate, this is the formula that I have to know about. But you know what's great about it is it's not the only formula. Not a lot of people talk about it, and we don't find a lot of literature about it. But always remember, it's the intuition that prevails. It's the intuition that should make sense. So it's high term frequency and low document frequency is what would make a document relevant enough, right? So what we talk about is the 2 points of our intuition was high term frequency and low document frequency. So just say that it is inversely proportional to document frequency. It never talked about having a log or having an n divided by something, which means we can use any function that satisfies this thing. If we can use any function to as in our TF-IDF formula as part of IDF, right? And this is what the beauty is. So y equal to e raised to minus x is the most common one that basically y equal to log of 1 upon x is something that we have seen as a most common one. But any function that is having a negative growth, any function having a negative growth rate would do. So y equal to e raised to minus x, y equal to 1 minus x, any function with a negative growth would do the job for us, right? So there are, if you're actually diving into and building this IR system, also consider changing the IDF function at your will. Any function that would do that would have a negative growth might work, right? So you can just play around some parameters, tune some parameters, and you might get a very interesting set of function that would serve you well than a traditional IDF function. And so always keep your eyes open. It's all about like being curious about it. Why only this? Why not that? Right. So there is no compulsion that you have to use log. It's the most widely popular implementation of it, but it's not restrictive. You can change this function at will. One thing that we would cover is around TF-IDF before we go on a break. Is like up till now, when we're talking about it, it's all about having one term, right? But what if there are multiple terms? Okay, what if there are multiple terms like this? So how would you address, like say, because search query is not just one term that people are searching for. There could be just say iron man, iron space man. There are 2 queries. Like what would we do with TF-IDF in that case? Because here this T is just one term, right? How would we solve this problem? I'll start with the intuition. Okay. So what should we do? This is straightforward. TF term frequency, but log is something which would make things a little complicated when we talk about it. When you have multiple terms, how would you deal with this? So if you say this is very familiar, this is very familiar to what? Probability, right? So n divided by document frequency, right? What's the probability of a word being present, of a word with a document frequency df being present in a corpus of size n? It would be df upon n, correct? Because it's the number of documents in the word is present divided by total number of documents is what the probability is. So probability that a random document picked from the corpus of n documents contains the term t is nothing but df upon n. और उसका inverse किया तो it becomes n upon df. So if you see this particular part, this particular interesting looking part, n upon df is nothing but a probability of we finding the word in the corpus, right? So if the probability is higher, which means it is adding lesser value to it, right? It's just that. So this is what makes this formula golden. बहुत मजा आएगा. So probability of finding the term t in the corpus is given by probability of t equal to document frequency of t divided by n, right? But our IDF, and so our IDF is what? It is logarithm of 1 upon probability, because our IDF function was log of n divided by df of t. Now n divided by df of t is nothing but 1 upon probability. Log of 1 upon x is minus log x. So IDF is nothing but a negative log of probability of t, right? This part. Now, when we have two terms in my search query, and let's say two terms, they are mutually exclusive events. So which means that there is no chance that the occurrence of two words, they are not in any way correlated to each other. So in that case, probability of T1 and T2 is equal to probability of T1 into probability of T2. Correct. So two mutually exclusive events पे probability का multiplication होता है. बराबर. So now what happens with IDF now? Now IDF of T1 and T2, because this is what we have to solve for. Like IDF of T1 and T2 is what we have to solve for, because एक term नहीं है, there are multiple terms. So IDF of T1 and T2. Now when T1 and T2 are mutually exclusive, it will be equal to, so IDF of T1 is equal to minus log of probability of T. So T1 and T2 क्या होगा? Minus log of probability of T1 and T2, which is nothing but multiplication of T1 and T2 minus log T. Then when we do this, log of A into B is log A plus log B. अब ये minus sign continues as is. Minus sign propagate is minus log PT1 plus minus log PT2. Correct? Once we have this, this is nothing but what? IDF of T1, and this is IDF of T2. Correct? See this. IDF is nothing but minus log of probability. So minus log of probability is IDF. So this is the beauty of it. When you have multiple search terms, the IDF of the conjunction of the two terms is nothing but the summation of IDF. So very, very computationally efficient. Matlab, it's so cheap to compute. Matlab, you don't have to have any complicated mathematical functions when you have like multiple search terms in your query. It becomes so simple. All you have to do is just add the IDFs, right? And this is what makes TF IDF golden. So IDF of T1 and T2 is equal to summation of IDF of T1 and IDF of T2. So my overall score for a document, for a search query T, now the search query can have multiple terms, is equal to summation of all the terms in the query queue pe, the relevance score of that term. So for all the terms present in my search query, the summation of TF IDF for each term in my search query ka summation is nothing but my overall TF IDF. And that is exactly why when we compute TF IDF, when we have multiple queries there, we sum all the TF IDF. We do not multiply, we do not apply any mathematical function. We just do a blunt sum of it, and that would give an overall relevance score of a TF IDF for my given search query. And this is what makes TF IDF very special. Yeah, Amrish?
But that applies only if there's an intersection, I mean, mutually exclusive case, right?
In most cases, so that's the fair assumption. Na? Otherwise, how will you find it out?
Yeah.
But even if you don't do that, you can basically fairly assume that they are mutually exclusive events.
But there can be case when both the events are present in the same document, then it's not mutually exclusive.
But then how will you even identify that? These two words always come together.
Yeah.
But what if user just typed in one word but did not type in another word?
Mm-hmm.
From the query inputs perspective, these are mutually exclusive events. You cannot always say that people who are typing iron will always type man.
Mm-hmm.
Right? So for you, it has to be the worst case. Worst case is everything is mutually exclusive, because from the user's input perspective,
Mm-hmm.
words are mutually exclusive. Because user can choose to type whatever he or she just wants to. Right? That's why. That's exactly why you'd have to assume that the events that are happening, they're mutually exclusive events.
Okay.
Right? But obviously there are complicated algorithms that take into consider, but instead of we worrying or we making this formula complicated, a better way to do it is by applying a different model for such use cases. Like these would give us a very nice basic ranking structure, and then we would apply another factor to it, and then basically compute a global score out of it. This is what is a very general practice out there. Okay, so now before we go on a break, we'll talk about like bettering relevance. So we built a very simple looking search engine. So how do we do this? Like one great example that we took was the word the. We would want to rank the Wikipedia's page of the on top, because what we typically do is we give different weights to different fields. So if a word is present in the title of the document, that document becomes more relevant than the word is present in the body of the document. So if you just have, that is why, like if you see Google, you would see that basically title is ranked differently. So you have title, description of your website, and then you have the main HTML content. So depending on where it matches, it gives different weights to it. Let's say title is given 10x weight. So that's why people try to crunch in a lot of things in the title. So an example of it could be even YouTube. So YouTube, when you search something, the weight is given higher on the title than on the description. So if something matches on the title, you give it a higher weight, right? This is first. Second, there is fuzzy search, because people do typos. We all do typos. So your search engine would have to index the data such that it can handle. So it has typo tolerance. So the way to store these sort of words and match it efficiently, there is a structure called BK trees. You can basically take a look at it. Even for spell correction, because fuzzy search and spell corrections go hand in hand. Spell correction is what? Let's say you have words like cat, hat, bat, zat. Right. So when you have words like cat, hat, bat, zat, how would you search that? If you're doing fuzzy search, one problem that comes with fuzzy search is you say that up till 3 for my 3-character word, one typo is allowed. When you configure your search like this, for 3-character words, one typo is allowed, which means that if someone is typing cat, it would also match the document with hat, because it would assume that cat pay, it is a typo, and hat is like one edit distance away from it. So it would also match with hat, bat, and zat. This was a very common problem that I faced quite a lot when I was building search. So although we see that basically typo tolerance is something that we have to have in the system, but it comes at a very massive cost. It comes at this cost, like because with fuzzy search, it would assume that every single thing is a typo, and then it would check. So solution for this is to have a tiered approach, a tiered search, where the first search would assume that there is no typo at all, and you make a very strict search out of it. And then if you don't get any results, or if you get poor results, then you would go into a different mode. Okay, let's do a fuzzy search on that. Then synonym expansion, like USA and United States of America, right? या फिर UPSC and Union Public Service Commission. People, so there might be some courses in which UPSC word is present, or sorry, there might be some courses in which UPSC word is not present, but Union Public Service Commission is present, right? These become synonym, or rather even abbreviations. So you would have to handle that. Another example of synonym is home and house. What if someone searched for home, but the document does not contain home, but it contains house? Right? You should be able to surface that. Right? So you'd have to take into account that as well. Yeah, Amrish?
So to handle this, let's say fuzzy case thing, right? See a cat. So you have to go for all the combination 26 by.
We won't do that. It's the search engine who does that, but it does not go through combination. It stores the words in that form. So one data structure that you can explore is called BK trees.
Okay.
So BK trees arranges your words with respect to edit distances.
Okay.
So through that,
for a same word, it will be maintaining all these combinations.
It does not maintain the combination. These words should be present in your corpus, na? So let's say your corpus cat, hat, bat, zat, all 4 have to be present.
So whatever, let's say user enters the entry, let's say bat. So how will it get to know that he is looking for cat?
वो नहीं करेगा. It would search for bat and cat both.
Okay.
From
So-
all the words that you have, it would
Uh-huh.
find words that are in the edit distance. For example, you would have like list of all the words in your dictionary. Let's say cat, hat, bat, zat, all of these 4 words are present in your dictionary, along with 22,000 other. Okay. Now, when you're performing search, you are not just performing search for cat, but all the words that are within the same edit distance range of 1
Okay.
from cat. So it would get cat, hat, bat, and zat. It would use all of these 4 terms and make a search on them.
Okay. Yeah.
What very cheese है yeah, it's very bad. It impacts relevance by a massive margin.
If it's going to maintain all combination, it will be huge, right? It's very
It doesn't have to maintain combination. That's what the BK trees are meant for.
Okay.
It won't maintain all the combinations.
Similarly for synonym also, right? You maintain the synonym, or there
Yeah,
somewhere?
we'll have to have a synonymic list for all the words. So from the data set that we're operating on, we have to maintain a synonymic list. For us, what are synonyms? So it is domain specific. For example, I'll give an example. Let's say biryani and biryani, these two are synonym. You can put it into fuzzy match, right? Or even let's say you call it pulao, or you call it PULAO. So these look like, so these could fall into fuzzy search and synonyms. So few companies choose it to implement it using fuzzy search, but fuzzy search there is a problem. But if you know okay, this could very well be a synonym, you can do that. So handling it on synonymic level. So another example for this is कौन सा domain है इसका? Game of Thrones. So someone searching for GOT or someone searching for Game of Thrones. So although GOT is not a famous abbreviation, right? But it could be a synonym that you can leverage there, right? Similarly, there are phonetic corrections. So people typically don't know the spelling of it, but they know the sound of it. I'll give you a very nice example. What's the spelling of video?
Video VID.
Correct. But most people type VEDIO. Sounds completely plausible. अरे यही होता है, because after certain time I was also thinking कि VEDIO तो होती है spelling, because it was that common. So I just added this. So I just used a phonetic correction on top of it. If the words sound similar, then they are same. Okay. Another example of this is there was an educator in an academy called Mansoor Ali Kapungal. अब ये word मैंने बोला है Mansoor Ali Kapungal. How many people can even predict the correct spelling of it? It's extremely difficult, right? So that's where fuzzy searches were not working for him, but he was our top educator. So then that's where I introduced phonetic corrections there. Through that, even if people typed in some vague word, but it sounded like Mansoor Ali Kapungal, it used to match it and improved relevance by a massive margin. So all of these things, so just imagine every single of this thing happen when you are searching on Google, and that scale. It's a very massive problem at hand.
Yeah, I remember a blog on Medium where Flipkart has induced this fuzzy search, like for searching products from Flipkart, like remote areas, like rural areas. So they have difficulty in typing, don't have very smartphones, and like spellings won't be correct. So for that purpose, they have induced this. But I don't know what's the logic internally. Look like
यही करना होता है. See, these are all the possible strategies that are there for search engines. So you have to apply some of this. Right. The final one before we take on break is query segmentation. So people forget to type space. That's the biggest problem. Like people type a search query, but they forget to type in space. For example, someone searched for let's say plant kingdom. So PLANT and space nahi diya and they started typing kingdom. Now comes the problem. Now, given this thing, if I search this within my search engine, I won't find anything, because this is not a fuzzy search, because edit distance is massive, or you won't have this big of an edit distance to search for, and you'd find no results for this. But so that's where query segmentation comes into picture. What it says is, how will you segment your query into words, assuming that people have forgot to type in space at the correct places. So through this, you do it like you can search for plant space king space dump, or you can do for plant space kingdom, right? So identifying that these two exist and picking one of them is the problem of query segmentation. And this is another algorithm that we have to build to solve the problem. Right, so there are a couple of papers around this which we implemented to solve this problem. So query segmentation does not typically come out of the box. And it's something that we have to add as a plugin and implement it. So identifying where to add that correct space. It's a classical dynamic programming problem you might all have studied. And that's exactly what we do. We build on top of a vocabulary and build a system that understands this and it maximizes some score through which we get the best thing out there.
Yeah, it's very complicated, right? It's like word break.
Word break problem. Why word break. Yeah. Nice.
So for any fetch query that a user makes, right? So first, then it goes through this one of them, right? At least query segmentation. Then it passes through your final data.
To be really honest, सबके through जाता है.
सबके through, yeah, that's what, right?
सबके through जाना पड़ता है. You cannot even skip it.
कितना डिले हो जाएगा सिस्टम में, मतलब इतने
थोड़ा आता है. It affects the performance by a lot. So that's where what happens is there comes in places where they say basically to minimize this, that's why autocomplete feature is a gem, because autocomplete say people are typing something and if your autocomplete is good, people would go through the autocomplete and then they select it. So this way they would always get a good query on the backend. Right, so autocomplete feature helps them reduce volumes of such mistakes, number one. But in case if someone makes a raw query, the system goes through all of this step. It adds a little bit of delay, about 50 to 100 milliseconds.
So for any query, which one you have to apply? Fuzzy search, spell correction, synonym.
मैं सब लगाता हूँ.
So it's very difficult, right?
It is.
You don't know which one give result.
It is. So that's why we typically have first layer. So our search query goes to a microservice that would say कि कौन से we have to apply. You might have some custom logic depending on the domain that you are operating at, or given the query in the domain you are operating at, you would pick a certain that you would have to apply, and then you apply those, and then you basically form an Elasticsearch query and then fire it.
So query enrichment sort of a thing.
Yes.
So basically, fuzzy search is handled by Elasticsearch internally, right? So others you have to make custom.
Yes, custom
on top of that.
Yes.
Okay.
Okay. Chalo. Let's take a quick break till 5:35, and then abhi to maths is done. Now we'll come to our normal system design part where we'll be model recent searches, right? So the idea is to build recent searches of a certain user. How would you store it? How would you render it? And those parts. Okay. I'll take a quick break till 5:35, and then we'll resume recent searches from there. Chal, let's start and brainstorm around recent searches. So the idea here is we'd want to build a recent searches feature for a search box, and the idea is simple. You have a search box. The person clicks on it. As soon as person clicks on it, you want to render the queries that were made by the made by the user. Let's say last 5 queries out of it. Okay, that's what we have to render. Last 5 queries made by the user, and it has to be lightning fast because you can't spend a lot of time doing that. And how would you design the system?
Generally, there are two ways people follow in this, right? Either go by try approach and
Why try? You're not searching within your recent searches. You're just surfacing recent searches.
no, here whatever is the top 5 you have to give, right? All the time.
Not top 5, the last 5, most recent queries, recent searches.
Okay, it's not like how many times.
Recent searches, that's it.
Okay.
The last 5 searches that I made on the platform.
Seems like Redis could help us with this.
What would be your architecture then if you are having Redis?
Maybe like a list of like sort of like a hash where the key is the user ID and the value is the list of 5 strings.
That's a good start. That's a good start.
Or maybe a dictionary of all the searches and the search ID.
Okay. So the first thing is recommended. Let's say we have a list, we have a hash map where you have the user ID mapped with all the search queries.
It could be string or maybe an object, like maybe objects.
Correct. Let's say for now we have string. Okay. So if we have this and we store this on Redis, okay. But now what would happen is we are storing last 5, right? But then would you always keep this entry in Redis? Won't your memory be overflooded with this?
Arpit, we will also have this in browser cache. Like if it is the first 5, just the last recent 5, we can have it.
Okay, so browser cache is an optimization on top of this because you would want this to be cross devices.
Yeah.
Okay. If you want it to be persistent, then we can use Cassandra maybe.
But how? How? See, you can use any database, right? But how? So if you're storing it in Cassandra, but then are you also using Redis? Yes, no.
Right. You can use something like min heap of size k, right? Whatever is the recency. And
why would you want to go for a min heap?
I mean,
it's not top k, it's just most recent one.
Most
it could be stack data structure where
recency is depending on the time epoch time stamp, right?
But then it's just an array then.
No, because it's a dynamic, right? So whatever is the older, it will be edited out. I mean, removed. If you maintain the
queue makes sense. Queue makes perfect sense as a data structure, but how to store it in the database is something.
No, if you are maintaining a min heap kind of priority queue, and last which is the oldest one will be on the.
वो तो वैसे queue में से भी you can remove ना. Why do you want a priority queue? Because you are not doing insertion in the middle. You are always inserting at the back end, or rather basically rather at the front of the queue.
Right.
And then it's just an array.
Yeah, normal queue also will work. Normal queue also will work. Yeah.
Exactly.
Yeah.
So reduce the size. To reduce the size, can we like globally keep index these queries? And the queues are just referencing the IDs so that you reduce the size of these.
No, but I didn't just strings. It just strings, right? So the concern here is like, see, the first approach was like we'll store user ID and the search queries in Redis, right? And then another thing was mentioned, which is about browser cache, because when we do browser cache, it won't be cross devices. Now the problem is if you keep this information in Redis, will you do it for all the users, and will you be having this key to be stored basically perpetually till the end of time?
Is this
And
required per user basis?
yeah, per user basis. No, that's what the research says.
When the user logs in, right?
Yeah.
So until some time, when the user login is valid, till that time only we'll keep this in
Nice.
cache.
That's a good optimization. So user logs in, but there is not. Do you log in every time you open a website?
No, that's what I said, right? So until the login, that cache or session is valid, right, for the user, until it doesn't ask you to re-log in, right?
But so how frequently have you logged into your Instagram account?
What we can do is,
yeah,
we can use Cassandra as our source of truth, and we can use Redis in between. So while eviction, what we'll do is we'll use the updated cache and put an entry into our Cassandra. And when while fetching the details for the user, if it is not present in Redis, we'll fetch it from Cassandra.
Perfect, makes sense. But then, what about logging in? Are you considering logging in for that, or are you waiting for user to make that first click?
Yeah. So if the user clicks it, right, it's a trigger, right, or an event. And in that, when I get this event, if I don't have the data in Redis, I'll go fetch it from
which means when user is clicking on the bar, let's say it takes 3 seconds for you to get the data from Cassandra due to any reason, right? So then it would be a poor user experience. It should be like lightning fast. It should basically pop up.
As soon as you log in, you should get the data from
first time when the website is loaded.
Please go on, Vishal.
So when the website or app is loaded, right, that is an event for us.
Correct.
So user will take 1 or 2 seconds to go to search thing, right?
Yes.
So that time we have, right?
So basically, the trigger to fill that up, we always use cache such that we make a call to cache. If it is not there, then we go to DB and then populate the cache, right? In this case, we always think about trigger being the tab button. So when user taps, we make a call. But when we do this, and if the data is not present in the cache, obviously it won't be, right? So it would have to go to the database, and this code and this flow would be a lot slower. So if you want to have a very, very good UX for the user taps and immediately sees the recent searches, the best way to do it is, let's not have trigger as user tapping on the search bar. Let's have trigger as user doing an app open. Like app open or logging or logging in should be the trigger for you to populate the cache. So I'm deliberately inducing this hypothetical constraint so that we all are aware that the trigger is not always where it looks or basically where we actually traditionally see it. It depends on our use case, which would act as a trigger. So for us, in this case, if you want to have a great user experience, our trigger could be whenever the user is opening the app. Like, because when we are doing this, we are saying that, let's say on 90% of the time when user opens the app, the user goes to the search bar. If that is the case, then it's worth doing it. But if user, let's say if only 10% of time whenever user opens the app, user goes to the search bar, then this might be like we are populating the cache, but it is not even being used. So depending on the statistical data that you have, you will choose where exactly should be your trigger placed. Should it be placed on the tab click, or should it be placed on whenever user opens the app, right? So this is the decision that should be made depending on the data that you have, right? This is extremely critical when you're designing a good system, right? Because you would never want to waste the CPU cycles or memory or RAM or storage space, and if it is not being used ever, right, that would be a very poor design. So always keep in mind, right? So this is like a couple of things which I wanted to bring to the notes. Okay. What is the problem if we use a separate source of truth and Redis? Any concern that we see here? If we have a separate source of truth and Redis, because like now what would happen is, like if user comes in, we have recent searches in Redis and user made a search. Our source of truth is Cassandra, Redis is filled. Now Redis needs to be updated. How would that happen?
Write through or write back.
The write back. So whenever the user is performing search, the entry is also being made on Redis, right? Which solves the problem. Could there be any other concern with this architecture, or with respect to user experience? Could there be any concern here?
If one of the write fails, I mean, user
Write fails to what? Write fails on what?
Write back.
Redis or Cassandra, any of them. Other source of truth fails, then Redis will also fail the next time, right? Because it will fetch it from Redis.
But if the write on source of truth fails, मतलब तो फिर तो data is not there, which is okay. फिर तो कुछ कर नहीं सकते ना.
Better to put it in a queue and both should consume from the same queue to avoid such situation.
Or we can just write to Redis, and when it is evicted, we can write to Cassandra.
You do not have such hooks. You write to the Redis, and when it evicts, you typically do not get such hooks.
So there's no event for this.
Yeah. So you would anyway have to do that, right? But think about from the user's experience perspective. So anytime user searches, the writes the query is logged in Cassandra, and you are parallelly writing it on Redis, right? Which makes sense because it gives a great user experience because all the gets are happening through Redis. So it serves very well. Right? With respect to user experience, that's what I'm more concerned about. User experience. Think about it. Think about what could be the edge case of your system. Think a little bit from the product side.
Instead of while searching, just instead of putting it there, just put it as an event and then process it. Basically, whenever search happens, publish an event instead of, and then
that is okay. I would recommend कि immediately कर दो. Do not put it in this thing because then it would be like real time. Otherwise, it is not real time. There might be a lag. And if your consumers are down, the lag might go even for hours. So I would definitely not recommend that because like basically Redis can handle that much of load. But think from a product's perspective. Think from a product perspective, what could go wrong with this architecture or with the flow that we have talked about. We have not talked about two edge cases yet. Chalo, I'll give you one. What if user, the user tapped on the search bar and you showed the recent searches and user tapped on one of the searches. Okay, it would fire a search query. You would make an entry in Redis. So next time user would see the same entry again, right? So you'd get duplicate entries in your recent searches. Yes, no?
Yeah, it will be appended again.
Right? Correct. And not rather appended, but rather prepended because you would see the most recent first.
Yeah.
Right. Now this would add because basically this is a very poor user experience. And why is this very important? Because as an engineer, we should always think from this thing because this would actually give our system a very good shape. We have to consider all the edge cases. Now, how would you handle this thing?
Maintain a sorted set, right? And
where
in the Redis, and remove that query and then put at that way.
Sorted set of what? Sorted set of strings. Then you're losing out on time.
Yeah, based on time. So if that exists, remove it and then add it, right?
So you cannot use sorted set on time basis. You would have to still use list and then remove it on that. If the entry exists, you won't add it. Right? That's one edge case. But will you not make a query, but rather will you not make a store or basically will you not persist it in your source of truth then? How would you handle this on the source of truth side?
Source of truth.
Yeah, I mean, the last click time would change, right?
So basically, Cassandra case last timestamp will win, right?
So you'll be constantly updating the entries then.
If we are maintaining using Cassandra, if we are updating, so this situation of duplicate will not arise, right?
Think about it. Amrish, please think about all the scenarios. Think. There are so many loopholes in your approach. Okay. Okay. Whose idea was it to use Cassandra?
Mine.
Acha, yeah, Piyush, batao. What kind of structure are you having on Cassandra? What are you storing, and then how will you use it?
वहाँ पे भी same था ना? User ID.
You would have a user ID as your partition key, and user ID, this becomes your key, and your list becomes the value.
Right. So I'm just picking the list from Redis. So I'm expecting that Redis would handle the duplicacy wala part.
But then you are just having user and list. Right? Now what you are losing on is a lot of rich information. What if I want to find out in last 1 year what was the most search query of a user? Nahi hai na? Because then this is actually not your source of truth then. Right? Because then you are losing out on the precious information about historical search log of a user. Because let's say tomorrow we are storing last 5 searches. Let's say if next day PM comes in, let's say we would want to have search on top of historical searches made by the user. Worst, I'll give you one very interesting story here. We got an FIR for some educator and some learner, and police asked us for search history record of that user for last 1 year. Not just IP and all, it was search history record were also asked from us because that learner was stalking the teacher.
So, but in this case, if the system doesn't do tracking, then
तो वो तो गलत होगा ना, because this is your recent searches का microservice, you would have to have that. So what would you store? So what would you store in Cassandra?
So query and a timestamp.
Correct. Because like for example, you would not just store user ID and list against it. You should typically be storing in your NoSQL storage or any storage that you have. What you should be storing is you should be storing all the queries that were made, all the query and the user ID and the timestamp. This is what you should be storing as a normal JSON documents here. Right? If you just store user ID and list of queries or some objects against it, you are losing out on historical data, which is something that you should not be doing, because like the historical search queries are the gold mines that you can use to improve your search. Right? Because if you are not storing that information, you cannot make your system better. Like you can do query analysis and then find out which are the most common typos that people are making, and you can use that to add as a synonym or use that as an abbreviation. Like for example, if let's say my system always had that UPSC, right, but it never had it always stored Union Public Service Commission, and it never stored UPSC ever, right? So what would happen? Just give me a minute, my child is. कुछ 2 मिनट जाना बा सोनू इसको लेना So you need to have that historical search queries present in your system. You can improve your search experience by a massive factor if you have the data. If you never have the data, like for example, another piece of critical information would be what's the typical search pattern of your system? Like what kind of queries are people searching when and why and how? For example, just before UPSC exam, people search a lot about UPSC. And you would get that concrete result when you have historical search queries in your system. If you would never have that data, you cannot do that analysis. Right? So typically what you should be doing, you should be having a structure like this, wherein all the search queries are stored in a certain database in order of a timestamp partitioned by user. So user and timestamp, you are partitioning and you are storing all the queries made by the user as different objects. Any concerns with this thing?
So Cassandra itself maintains the timestamp whenever you do the entry, right? So do we need to explicitly maintain the timestamp?
जो भी database. I'm not just dealing with Cassandra. I pick DynamoDB, Elasticsearch.
Oh, okay. So if you don't have,
you have timestamp. You need to have timestamp so that you understand what kind of order are you are people searching from. Another great optimization that I did with this is like people searching for, like, typically what happens is, in order to identify bad queries in your system, like, see, as an engineer, you have to think about a lot of edge cases, right? So a lot of human behavior as well. So what happened was people typically search for something and then they immediately search for something else if the first thing did not yield into good results. Like what you search for on Google, think about it. You are searching for something, you didn't find good result, you immediately add 1 or 2 more terms to your search queries. Right? This is a great way to understand that, okay, this was a bad query, or basically this was an old query on which I did not give a good result. The user added these 2 more words into it. If you have that data, then only you can make your systems better. Right? So you typically need to have a database in which you are storing all the historical search queries made by a user. And this would be your source of truth. Everyone agrees?
Right. Yeah.
Right. So, given this, now how would your system, look like? Because your recent search queries has, like, let's say you're surfacing 5 out of it. Your source of truth is Cassandra having user ID, partition data. You can use Cassandra, DynamoDB, Elasticsearch, any database you want. Now the structure is very different on both ends. Now what is the problem here? When someone searched for something, you made so are you making an entry in Cassandra? So now how are you making entry in Cassandra Piyush? You are creating a new object there. Now how are you populating Redis there?
You have to check if it is already present, and then
that to Redis mein ho gaya, right? And for Cassandra, you are just logging it as is, right? So your Cassandra is sorted, but with Redis, there is this problem of duplicate entries, no? Because in your source of truth, you might have like, let's say user clicked on the same recent query 3 times back to back. Now you'd have to pull out the unique queries. Then your product experience would be good, right? So how would you handle that? So you're on the front end, you want to render, or your API should render most recent 5 unique recent queries made by the user. And on your source of truth, you might have duplicate entries because that's what you're storing. Like every time user made a search, you are making a new entry there.
Right. So fetching the latest I would not work because maybe the user has searched this for 5 times. Yeah.
Yes. So how will you address that situation? Simple hai. Guys, come on.
Unique चलेगा क्या?
Unique नहीं चलेगा ना. No simple तो unique करोगे हालत खराब हो जाएगी.
हाँ.
Can't do unique. Guys, simple. What's the hack that you can apply? I'm sure Varun might have an answer for this. Varun, come on.
We can fetch a lot of entries, maybe like top 100 and pick up the 5.
100 from ज़्यादा हो गया. Let's do 3x, right? And through this, you're not eradicating the problem. I'm not saying that we are eradicating the problem. We are just minimizing the chances an average user would see poor or would have a poor experience. So what we would typically do is we would typically fetch 3x entries and then we would, we would eliminate the duplicate out of it, sort it by time, and then return it as a to the end user. Now the worst case would be, let's say we want to render 5, we fetch 15, and let's say all 15 are same. In that case, it's a product call, by the way, but we can say that this is a very extreme case that has happened. So what we can typically do is we can we'll just render 1 on the UI. So if the product is okay with that, that's fine. And you should have these sort of edge cases being tracked. This was happened, like I fetched 5, but I returned this thing. So these two metrics is something that you should be constantly monitoring. How many were fetched from your source and how many did you return to the user? This is a very interesting metric that you should be keeping track of, which would give you that how many times users saw less than 5 results on the front end side. Right? समझा benefit उस चीज का? Sure. And will be building exactly this. So we have anyway covered almost all of it, but just to summarize it well and just to cover a few pieces here and there. This is not something just made up for this. This is running in production. This is exactly what I've built, and I was a PM and developer and everything for this. So this is exactly what I designed and the kind of metrics that I track in order to understand that my users are getting the best experience. So basically this is exactly what my architecture looked like. But just instead of Cassandra, I've used Elasticsearch, because Elasticsearch is our source of truth for all the search queries that goes in, and we fetch that. And the reason we stored it on Redis, I'll basically come to that why I made that switch. Maza aayega uska. Okay. So the idea is simple. When anyone taps on the search bar, you have to render the last 5 search queries made by the user, which has to be unique. The high level architecture would be simple. Up till now, when the search API comes in, user fires a search API, goes to the API server fires a search request, which goes to Elasticsearch. Right? The Elasticsearch computes the search results, gets you the results, gets the result of the API server. API server then sends back the result to the end user. Right? Now, this is a very traditional looking architecture for handling search. But now what would come is, to handle the recent searches made by the user, we have to log the recent searches made by the user. So that would go for in a separate DB. So my current architecture, my search query log and search database, both are just on one cluster. But typically when you are building it, you can have a separate storage. You can pick any NoSQL storage, because the kind of queries that would be making would always be user centric. So there would not be any foreign key references, any fancy stuff there. So you can use any NoSQL database, partition it by user ID, and you are good with that. Okay. So the idea would be, you can pick any database. So Elasticsearch, DynamoDB, Cassandra, whichever you are comfortable with, even Mongo, or even a sharded MySQL. Pick any, but it has to be sharded. That's when you would get a nice scale out of it. So search query, whenever search query comes to the API server will log it to this database. Would first search the Elasticsearch, would first perform a search on Elasticsearch, and then it would store it in this database and then return the results to the user. Right. This way we can add more checks to it. Let's say if tomorrow product comes and says that we don't want to log queries that yielded in no results, right? Because just assume that people are searching some random something, some blah blah, and it gave 0 results. Would you still want to give the real estate of your screen to that search query? In most cases, no. Right. So that's why you first have to fetch the data from Elasticsearch and then see if there are any results. If there are, then you store it in the search data in the search query database. Otherwise, you would not store it. Right. So all of these things become very critical in basically designing an architecture like this. So critical questions. How old of recent queries do we want to serve? Right. Let's say if a user came onto the platform after 30 days, would you still want to surface the recent queries made by him or her? No, basically decide that, because these are critical questions that would help us design the systems. For example, our source of truth, which is the NoSQL database that we were talking about, can be, because if it is having, so the access pattern of our data, the way we would be using this recent searches wala database is what we would be always fetching the most recent n entries out of it, right? Which means that historical data might never be queried, which is eating up a lot of space, right? It is costing us money to have such a massive NoSQL cluster running, right? So can we archive the data? Let's say it's a product call. We would never surface, or let's say if it is 30 days that user has joined, we would not surface the recent searches for that user, and we don't want to store it even, right? So we can archive the data and store it on S3. But this way we would save money and storage space and database computation power and database indexes and whatnot. So we would have a very nice solution for that. So these are all critical questions that you have to ask. Like, then do we want to serve repeated queries fired back to back? This is what, like searching Tendulkar queries, this is what we were talking about. As an end user experience, would you want to surface two Sachin Tendulkars or just one? Okay. Should we serve all the queries even if user did nothing after the search? So if search was fired onto the database and if it resulted into no results, versus another thing that user searched for something but never clicked on an item. And let's say if I don't want to search, let's say if I don't want to store this thing, like some weird product requirements, if it comes in, right? Would you want to do that? Should we serve queries with no results? This is what I was talking about. So queries that went to Elasticsearch resulted in no results. Would you still want to log it and surface it in your recent queries or not? Right? You would have to take that call. Okay? What? Because these are all your filters that you will be applying. Then how many recent queries do we need to store? Because if on recent queries you are storing 10 or 15, how many are you rendering on the first place? We were talking about 5, but it could be configurable for the user. So in some apps, it is configuration. Okay, how many recent queries do you want to see? Just say like 5, 10, 15, depending on how frequently is user using that. And one query and one question which I did not add, but would take this system design, would take this system to a very different level, maybe out of scope for this one, is should we allow user to search in the recent searches? Because if that's the case, then it becomes a very different problem altogether. Because now we would have to create search engine on top of the queries which are fired by the user. So वो एक अलग problem हो जाता है. But yeah, these are very interesting set of questions that would help us give a very nice shape to this thing. Okay. Just Amrish, let me cover this topic and then we'll take questions.
Okay.
So our architecture for now would be like we have our end user firing search query, goes to this API server. API server performs the search on Elasticsearch, gets the result back, and then this API server chooses to store the query in our query store. Pick Elasticsearch, any NoSQL database you want, Elasticsearch, DynamoDB, MongoDB, whatever, and it would be storing here. So this table would just store the search query which was fired by user on this time. That's it. That's all it would do. And if you'd want to have this extra check that, like, if the search query resulted into nothing, I don't want to store it, then you would have that extra check in the flow, right? Each document of a query store might look something like this. You would have an ID which is like randomly generated by your database, Elasticsearch, whatever it is. Then you would have the search query which was fired. This is something that would be rendered on the screen. Then comes the timestamp. Like at what time did the user file this query? Epoch millis you can store. Total number of results, that when I'm storing this query, when it was fired all through the database, it yielded 72 results. This is very important because through this we can add that filter. So we can still fetch more data, more queries from our source of truth, and then we can filter out queries which did not resulted into any, which did not yielded any results, if that's the case, right? So, and plus some analytics purpose we can use it. And then more importantly, who made that query, right? Because it has to be very specific to that user. So one very extension of this problem is like, just think about designing medium plugs. You'd find a very similar architecture to this. And one more thing that I would like to add is design CRICbus. So where live commentary happens. So live commentary of it. And it has to be very, 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 very fast, right? These two are very similar questions to recent searches. I've just plugged it in here so that I don't forget. Okay, just think about these two problem statements and see how you can design it. Okay. Now coming back to our recent searches. So what if product requirement says that register a search query in recent searches only when user makes a click on the result. So this is even one level after it, right? Log it into this database only after user searched for it and then clicked on one of the results, then only record it. If that's the case, then you might have to have a separate endpoint which does logging of the query. And now let's say this would come in handy when user first, so the flow for this thing would be that your user has made a search request, goes to the API server, goes to Elasticsearch, and the results are returned. Then let's say when user clicks on one of the results, the client would make a query on /log, and then it would be storing the query in Elasticsearch. So this would be a new flow which would be added. So depending on when you would want to log it, right, that's when you would be taking this call. Okay, this is when I would want to log it. Right. So there are places. So depending on the requirements that comes in, you would have to keep your systems, you would have to alter your systems accordingly. So always keep that in mind. So other architectures that you can have for this thing to store search queries is you can use an event store, something like a Redshift, right? A very cheap storage for analytics purpose. You can store it on NoSQL, normal DynamoDB, something. You can also store it on a data warehouse where an analytics query goes in, but it might give a very poor performance. Although it is meant for analytics, it seems very tempting to use one, but it would give a very poor response time when your data is not there in the cache. Very poor response time. So you should not be using that. You can use an event. So I just written it as a thing that although it looks like a perfect use case for that, but it is not recommended to use it because it is not real time. And it takes a lot of time for the Redshift to compute all the analytics based queries. So it's not meant for that. So yeah, now comes to the get queries part of it. So we'll make like query like /search/recent by get. It would get all the recent queries fired by the user. It would go to the query store and get the data. Now this query store was a NoSQL data store, right? So in that NoSQL data store, in which for that given users, you'll get the last, let's say 3x. Let's say you don't want to render 5, you'll get last 15 queries out of it, and you'll pick the most recent unique 5 queries and you'll be returning it, right? So user makes a request on the tab to get the recent queries. The request is forwarded to the query store, SQL, Elasticsearch request, whatever it is. The response is received from the query store and is returned back to the user. Yeah. Now, if we don't want to send duplicates, this is what we have discussed. We fetch more than we need. So answer is fetch more than we need and remove duplicates. So depending on the threshold of tolerance, right, you would pick as many like 3x, 4x, 5x, because your query store will also need to handle that much of load, right? So always keep in the mind that search is one of the heaviest system in any product, because it gets the it is almost it is easily it easily comes in the top 5 heavy throughput services in any org, right? So there would be a lot of reads and a lot of writes happening on your search storage engines always. So depending on the amount of data, it's easy to say theoretically, okay, we'll read 3x data. I started reading 5x data and the performance of my search cluster fell by 50%. Right. So my CPU was always overclocking, my response time shot up like anything. Like, so my response time literally became doubled when I just turned it to 5x. I tuned it back to 3x, degrading user experience. Like, there were a little more cases when users saw repeated queries. Oh, sorry, when users are less than 5 results there, but my search cluster was a little healthy there. Right. So this is where the high throughput comes in. You always have to be in mind. Not with respect to interview, you would have to say that. But while working, always keep in mind that 3x, 4x, 5x seems like a random number, but you'd have to start with something and then see how your storage engines respond to such load, and then you'll be making a call according to that, because your query store always has to take in a lot of writes and reads when your cache is not there, right? So reads are less but writes are more, and every single search query being logged there would add a lot of pressure onto the database. So always be wary of that fact. Okay. So now, if now the problem comes in, like since your query will always be under load because a lot of requests are coming in, always fetching 30, 50 entries out of it might make system very slower. Your database slower, which would add a lot of response, which would add a lot of latency to your API. So this is exactly what I faced. So when I built recent searches, we are using Elasticsearch for that. We were seeing a lot of write throughput on that. And what happened was that our response time for recent searches were average response time was 3.5 seconds, which is too slow for anything by any standard. So we had to make it single digit millisecond. This is what my goal was. So it was a very moonshot sort of goal that I had in mind. So this is what we designed. So instead of querying it on the query store, we added Redis. So what we definitely knew was Redis was faster. That's for sure because it stores data in memory. It could be a little costly if you're storing recent queries of all the users in just Redis and not storing on query store because that does not make sense because volatility data needs to be durable. So we added Redis. So we know that get on the Redis, even at a very high read throughput, is still, it floats around 15 milliseconds as P99 as P99.99 wale pe. So it's a very good choice for us. So we decided this that we'll be using Redis as this. So which means that my get request. So what I did was my get request only and only goes to Redis. If the data is there on the Redis, I get the data and return it. If the data is not in the Redis, I would see that no results or no recent queries for this user. Like we were okay with that. We were okay with that even the user has made some queries, but we would still show no recent queries for that user because it's not an end of the world for user to not see recent searches, right? So that's where what we did was we picked up this place that we would want to just keep our Redis updated. So our flow is whenever we need data, or basically now the question is how our Redis will get populated. Either cache miss pe I can go to the query store, get the data and populate in the Redis, but it is obviously not recommended because we want very fast response times. So whenever the search happens, it would trigger the job and it would populate the Redis, or when user logs in, then populate the Redis and that would come up. So these are all like common and traditional way to do it. But few edge cases, again, limitations of this approach, the one I was talking about, that empty recent searches till the data is filled. So let's say if you have a trigger in place, like let's say when user app open event fire to prefill the data. So let's say your trigger is when user opens the app, you trigger a job that would prefill the recent queries of that user from the source of truth, filling it into the cache. But let's say this takes 3 minutes, and within that time, user immediately tapped on the search bar and tapped on the recent, or no, basically tapped on the search bar. Once user did that, you would see, he or she would see no recent searches. Like that is the only place where my system would falter. So my job would be to ensure that the lag from user's app open, like, or basically from the lag from the event being received till the time the recent cache is, or the recent search cache is filled, it has to be less than some X seconds. You can decide whatever your SL is, right? So pick on that part, and you would be want to scaling your burger nodes according to that, right? So this is a great way to build this analysis. So your get would always go to Redis. Your trigger would be placed on either placed on app open or user login, which would create a job, would go to your asynchronous worker. So your high level architecture for this would look something like this. So your user is there, your user, this is your API server. Let's say your event came in for, let's say, /app open, something event came in, it would trigger a job, it would publish a message in a queue. Let's say pushed it in a, let's say we have an event bus here. Let's say we have Kafka and we have some consumers around it. The job of this consumer would be to take this event, pick up our main query store. So this would read from the query store and we would have a cache here. and this would read from the query store and update it in the cache. Now, whenever my request for slash search slash recent comes in slash search slash recent, it would go to the cache and get the result. And when my request for slash search comes in, it would go here and it would store the information in the query store, and you would have a Elasticsearch cluster here like this. Something similar to this, right? So you'd still have your Elasticsearch cluster. You would have a separate query store. You would have a separate cache. Your slash search slash recent get request would always go to the cache and get the result and respond. Your app open event would be consumed through Kafka. Would come to API server, would be streamed to Kafka. From your Kafka, your consumers would listen and would immediately process that event, and using the query store would populate the data in the cache. Once the data is populated in the cache, your slash search slash recent query would start seeing the data. This way, you can ensure that your response time is strictly under single digit millisecond in P99 case. Got it? So this has a lot of Lego blocks. Whenever we are deciding or whenever we are designing a system like this, where it needs to be perceivably fast, that's when you would use Redis as your database to perform gets on that, and then have an asynchronous job that would basically populate the cache. This is a very common pattern in a lot of systems out there. So if you'll build medium claps and ClickBus, you can use a very similar technique like this to implement that thing very well. Any questions here?
Question is related to that when like query is successful and the user is using that from the log, right? You explained some slides back. Not this one. I mean response, whether he is using the response or not, this one. So how does both gets related? I mean,
who gets related what?
I mean, whatever search response he has got, whether user has used it or not. So triggered from the client side.
Front end pe clicks hogi na. So your client pe in your JavaScript thing, whenever someone is clicking on the search result, there is JavaScript. You can have on-click listeners on that. And that would make one call to slash log thing and then redirect the user to the actual search page. You'll have click listener set up on your front end side.
Oh, actually, I never worked in front end. So
whenever you click a button, you click a link, there are listeners which are fired. On that you can configure to invoke this API.
Oh, okay.
So guys, please do design systems, do design of ClickBuzz and medium clap. ClickBuzz live commentary has to be lightning fast, because you would also be scrolling right now. India versus England is going on. You would be continuously scrolling it. What's the score, especially during a tense match. There are lots of calls getting there, and you see that response time is almost near constant for that API. Think about how they would have built it. Similarly, medium claps, where you would want to have like a clap done by user on an article is capped at 50, and how will you surface it and make it real time? That's it. That's even fun. That let's say, think about it, like on Medium, if there are like 50,000 people reading one same article at the same time, and if one person claps it, everyone else also sees that clap happening there in real time. Like, think about that. And although it seems like why would Medium do that? Another great place is Instagram Live. Instagram Live page, someone gives a heart when someone is live, everyone else sees it, right? So all that seems like just medium class ka problem, but you can see it in action at a lot of other places. So if you just build one system and understand the Lego blocks, you can build any system out there, right? You would have to go back and revisit our sockets wala thing, the way we scaled sockets and all, and making it real time using sockets, storing it in database, using cache to get the count and all, and basically designing it. So think about this in depth. How would you design medium claps, that to real time updations and all, and ClickBuzz live commentary? it would would have a very similar architecture to this. So that's why I've just plugged it into just to let you guys know that the same sort of high level architecture would be there to solve like seemingly unrelated problem statements. Right.
So
yeah.
Only difference would be like real time. I mean, publishing, right? That
Right.
will be through WebSocket.
Yes. Yes.
Otherwise, all are same.
Yeah. Yeah. Well, not exactly the same, but obviously
Yeah.
you would see
Yeah.
a very high resemblance
Yeah. Yeah.
in the way systems happen. And also build this thing. Build did you mean and related searches, not recent searches, but related searches. Like these are like information retrieval specific. Like if you misspell something on Google, Google says that did you mean this? Right? If you were to implement this, how will you do it? Right. And then another one would be related searches. If you search for Sachin Tendulkar, you might get about 8 or 9 related searches at the end of the page. Right? How would you build that part? So these are like IR specific problems, basically information retrieval specific problems, but it's very simple to implement. Try that. I've implemented both of them anyways, so I have a quite bit of idea. So if you want to have a chat about me with this, chat with me about this, feel free to ping me. Okay. Yeah. Now, this is exactly what I wanted to cover. In case, so now I'll open up the forum for questions. Yeah. Yeah, Bhupendra, you have any question?
Yeah, I just wanted to share 1.5 years ago, I think in Hotstar, I was asked the similar thing to design Hotstar like something that is live. When live match is coming, they have lights popping up. I didn't bomb it, but it was quite bad. So after that, like that was the final round, and till that time I was very confident. And this round I screwed up.
Yeah, there always comes that one dreadful round. But definitely you would have studied it like very extensively how to build that. So you would do anyway a great job. But in case if you develop, you can build. If you can build that part, because that's when the first core challenge would be scaling up sockets. Second would be streaming it to to do a selective streaming if required, and basically real-time updates ka broadcast, and storing and rather more importantly storing it in a high throughput way. Actually, let's have this discussion. This is a very interesting problem. Like when such events happen, like when so many people are live, it's very hard to register the reactions to have such a high write throughput system, right? So because you would want to also store it in the source of truth, right? So it's not just basically ephemeral data which would just vanish away after some time. You would also want to store that thing ki this user gave likes at this time. Like how will you store that information? How will you have that high level of write throughput in your system and while making our APIs faster? Bhupendra, how would you do it?
I don't exactly remember what I said. After that, I read something, or then I forgot. I just remember.
Abhi kar lete na design, because this is a very interesting problem, right? So the problem statement is simple. There is a like button, right? Someone goes live. There is a heart button at the bottom right of it. You can press it any number of times, literally any number of times. Okay. When you press it, you see a hearts flying on the screen. Okay. When someone else presses it, they also see hearts flying on the screen, right? On your screen. So when someone else likes it, you also see hearts flying on that side. Okay. Now, communicating this is through sockets that we already discussed. Right? That's an easy problem. Interesting problem would be when no matter how many times user presses it, you would want to store each and every write that is happening. So each and every time user is pressing it, you want to store the event in your database. How will you model this?
I mean, it's a write heavy database.
Exactly.
So, yeah,
Exactly.
So Cassandra with a match ID and the reactions with the timestamp.
Register all the likes. So we basically correctly identified that this needs to be a very write heavy sort of workload, right? But then how would your API structure look like? How would you design this? So let's say you have a user, the request would come to your API server. Now you added your NoSQL storage, right? Your SQL storage won't work. You need to have NoSQL storage. Yes, no, everyone?
Yes.
Right? NoSQL storage clustered because it is sharded by some ID. But which ID? It would be like
Match ID.
Instas or basically either live ID or in case of Hotstar, it would be match ID. It would be partitioned by that because you want to render how many likes did this match received. So some sort of storage SQL and it gets stored here. So your request would be /register /live/like. Okay. Now, will you directly store it in NoSQL?
I mean, you can batch it just like and put it into. You can batch.
You can or you should.
Should, I mean, because I mean, see, when it's Cassandra, it's already log structures merged tree, right? And even the event hub or whatever you put in, it's also log structured. So I don't see the benefit of putting it in a event bus sort of thing in a batch way. Maybe batch write to disk is, I mean, database is okay. That's my opinion.
Maybe directly writing to in-memory cache and event way in NoSQL. That would help.
You can also bash on the client side, right? Maybe send it after 1 or 2 seconds. Collate it once and send it.
Anyone else wants to add? This is exactly, so these three were the exact point that I wanted to cover, right? I know you guys know all this stuff. So the first set of optimizations, so you should never invoke like on every like, you should not be calling an API or you shouldn't be making an API call. So always first point, batch on client side. So read about debouncing. So people who are not into front end, still read about debouncing, right? So batch on the client side, you typically debounce when you get a lot of requests. There's a logic of debouncing of very small JavaScript code, but you'd get a gist, like what exactly happens behind the scenes. So batch the request on the client side so that your API servers are not overwhelmed. So Varun, the point that you said that it's okay, it would not matter if I write it onto an event bus, which is also log structured, or if I write it onto Cassandra, which is also log structured. That is perfectly fine. But bombarding unnecessarily is something that you should be thinking about at first. That where else or through this system am I bombarding it? This should be the first thing that should come to your mind whenever you're building any system. Like, is there a chance of this system getting abused? Have I made it foolproof? Okay. So /live/like is something that is going to be triggered like at very fast. Like you have not seen how crazy people go on live when like something like I was just going through, I think it was Tanmay's live stream or something. Chat page, Tanmay just said just type painter OP or something, and people like crazily started typing painter. I'm like, pagal hai log. People do that. People do crazy things. This is something that we also face in the live chat. So on Unacademy, Virat and Anushka ka ek special class happened. So basically a class happened which was free of cost and anyone could join. So they were sharing their life learnings and all. And at that time we saw 75,000 concurrent learners, and Sala, every single one of them was continuously just bombarding on chat as if like those guys were reading it. Just hearts pounding all over the place. And like, man, and we were there managing in front, like, kya? Are we really handling load for this kind of data? Why? But at the end, that's how our end users are behaving, right? But we would have to respond well. So we never anticipated our chat system broke like anything. But then we learned a lot, and then we re-architected basically we re-architected all the stuff. Instead of using Cassandra, we used DynamoDB. We bashed it on the client side. Okay. Then instead of directly dumping onto database, I'll give you one example I'll give you one situation why you should not be directly dumping data like this into database directly, because you never know when that database is experiencing a write load, right? Because in most cases, the databases is not just to store this one kind of data. You would be clubbing other kind of data into this database as well. This database will piggyback some other data as well. And because just imagine now, spinning up a massive Cassandra cluster just to store live likes. Like that's not how real world systems are built. You would always piggyback 4 or 5 more things onto that cluster, right? So due to other service getting bombarded by some writes, you would not want this system to get affected, right? So it is always better to have a staging area in between. So you should typically, to avoid DB writes, load specifically, you would add a batch in between. So typically, you did a client-side batching. You registered one combined event for 1 minute, or let's say 15 seconds. So we basically place it at around 20 seconds. So how 20 seconds where one write goes in, if any. We accumulate all the writes that happen in it, and then we make one batch call. And in that, we make the like page account. So we have like 10 emojis that people can choose from. So for the 10 emoji, what's the count of it? Right. So this emoji was clicked 5 times, this emoji was clicked 6 times, this emoji was clicked 7 times, and we make this one batch call. This batch call goes there and it gets stuck in an event bus. And then we have consumers running here, whose job is to read the event and store it in the database. So this way, what we get benefit is, even if my database is experiencing a load, my event bus is meant to be handling this use case, because event bus write is just on disk and that's just it for one entity. Your database is actually supporting a little complex queries. So locking and all happens on the database. Your event bus has no locking ka concept. Has locking concept, but not handling analytics queries or handling big chunk or some queries that require CPU intensive work, or some entries getting logged and all. Your event bus is not meant to be serving that use case. So you would be dumping events into your event bus, and then your consumers can slowly pick up the content from the event bus and put it into your database slowly and steadily, as and when your database is healthy and well, it is basically storing it and throttling it when needed. So this way, just because your database can suffer from locks and all, avoid batch, locking on DB, complex queries. So these would affect performance of your live likes getting registered. See, and anyway, this is not as critical as I want to have this count stored in the database like in real time. Like this can go on for days if needed. Like, because it is not adding a lot of like basically pseudo constraints. No, I want to have like live counts immediately. Even if it happens after 3 hours, no, nothing is going bad, because at the end, in the front end, user is seeing that hearts flying now, so people are happy. They don't know ki piche kya count ja raha hai. So you can basically slow down the consumption. You can basically slow down the consumption of non-important events by adding a event store in. And this is where event store comes in very handy, right? So avoiding batch call, just give a minute, Piyush. So basically batching it on the client side, avoiding DB writes, and avoiding direct DB writes, by adding Kafka or any streaming solutions here, right? And then obviously the third point would be socket say real-time gratification. So real-time gratification to people where they see they and all, right? So these are the like key things that you can do. So batching it and client side, batching it on this, and DP pe tha. Okay. Yeah, I'll take question. Yeah, Piyush.
Why Kafka and why not message bus? मतलब क्या फर्क पड़ेगा उससे if you use some message bus?
Okay, so see these sort of events. So Kafka is log structured, so writes are very fast. Second thing, if this event needs to be consumed by other service, that could also happen, right? Third thing, message bus for everything. So typically the way you would be architecting it, let's say if your message bus or let's say if your message broker is, let's say, SQS and all, right? So वहाँ पे you would be underutilizing your SQS because SQS or any message broker would have a big blob ka chunk. So it's a network call that goes to any managed service versus this Kafka. If you are using it log structured, lightning fast, you can also add a very small payload into it. Third thing, Kafka also supports
I'm the
KSQL.
only one who lost Arpit.
What? Am I not audible?
You are audible.
Yeah, Varun, you were saying something.
I think I lost you. Yeah.
Okay. The reason, the primary reason of using Kafka would be if someone else wants to consume this event for analytics and all, can use it. Because these events would anyway be streamed from client side to be stored in your event store. You would anyway have that. So you can piggyback the existing things on top of this.
ठीक है समझा. And
उसमें check
writes
कर
are
लो,
much
बाकी सब तो
faster
चलेगा.
in Kafka than in message bus.
Message bus as in your वो
Maybe
Rabbit
SQS.
MQ है ना?
हाँ,
SQS
हाँ,
Rabbit MQ वाला ना?
हाँ.
हाँ, तो Kafka is a little faster because it is pure log structured storage. So SQS internally भी log structured ही होना चाहिए. I have not dived into internals of it, but Kafka definitely is because Kafka is famous for handling high throughput writes.
Acha. But for these use cases, what we can do is we can maybe use a message bus and have a separate set of consumers scaled for such
Correct,
events.
correct. Yeah, but in that case, one thing would happen is your API server, let's say tomorrow there comes in another consumer for that, you would have to create another message bus.
Message bus,
Right? That is thing that you would have to be ready for. And when you are using SQS, नहीं बाकी कुछ problem नहीं आएगी उसके वजह से तो that's it. Yeah, Chandra?
Yeah, so Arpit, as we talked about the like example, right, where number of likes are not important, but if there is a system where live polling is happening or the voting system happening, where we need to have the exact percentage, like how many people opted. So in that case, how can we handle that? Because we can't afford to have delays, right? So yeah, and everyone is seeing that
तो वहां पे
result.
हटा दो ना. वहां पे what you need to do is you need to ensure that if you are having Kafka in between, then the delay between the event being registered and the data being stored is minimal, right? You would adjust your concurrency according to that. You would adjust the number of workers according to that.
Okay.
You can also choose to immediately store the data into your storage because in that case your data store or your database will only be meant to serve this big use case because this is a critical use case. Right?
Yeah.
So the example that you're talking about is there's a tool called Mentimeter, Mentimeter. So that is exactly this, or a platform like Quizzes. So we built something very similar. So उसमें वही होता है कि real time poll happens and as and when I'm getting entries for the user, I want to immediately keep the data updated. So typically when we're doing this, what we do is all the analytics happen through Redis. If it's really short and very real time, everything happens through Redis, but I do have a source of truth in which in case my Redis fails, I can reload the data from my source of truth.
Okay, and that happens through a delay, right?
My write on Redis happens real time. So their Redis is similar to how we designed the recent searches now.
Yeah.
For that. So let's say just to avoid confusion, let's say what we are doing is we are doing real time polling, where I've opened a poll for 5 minutes. I've made the poll live, and as and when people are tapping on the options, I would immediately see like graph going up and down. Okay. If this is the use case that I want, then what I would do is I would add this thing in my Redis. Okay, I would still have a source of truth. So depending on the maximum number of registrants that I'm allowing, let's say it's 5,000 people or even 10,000 people. So whenever they are selecting any option, the API call the request comes to the API. API servers updates it in the Redis. Okay. Once a while, let's say once every 5 seconds. Obviously, this is a very short time, right? Because my poll is live only for 5 to 10 minutes. But at max, it's basically 5 minutes. If my poll is live only for 5 minutes, and if I want to show that real time of graph going up and down, I'll store it on Redis because everyone is having their eye on that, right? So all the people who are participating in the poll and let's say the educator, everybody is having an eye on that. So I'd store all of this data in Redis, and once a while on the interface of everyone, they would have a short polling enabled. That every 5 seconds make an API call and get the poll ka status. Right. And this event, this API, when it gets the event for the user, it stores it in Redis, but also it stores it in the database. And this can go through Kafka, right? Because this can be slower. But if you want to have like strong consistency, you can directly store it in the database because this is a big enough use case for your data to not expect any delay to be reaching to your source of truth.
Yeah, correct.
I hope that clears up.
Yeah, that does.
Awesome. ऐसे डिस्कशन में बड़ा मजा आता है. चलो, any other question, guys?
Arpit, you have this. You built the live chat thing, right? That also involves...
I did not. I was part of discussion, but technically I did not build it, but I know क्या किया उन्होंने. हाँ.
But that also involves like kind of broadcasting others' messages. So when
socket आयो. वही जैसा I talked in the first couple of weeks, ना? Same architecture.
In that case, like you will maybe strip some of the messages, not send all of them, just to
नहीं भेजते उड़ा देते. Because we know that when classes happen at this scale, na, will educator go through all of the message of student? Do we want all of those messages to be stored? So it's okay our messages get lost, and we are okay with that.
So Arpit, in case of multiple classes going online, so you will associate those with the class ID or live ID,
yes,
right?
Yes. Everything is partitioned by that.
Okay.
I just had one question, as in this was not related to what we discussed, or maybe I like right now is working on Celery. So like how exactly like मेरे को बस बोला गया था, तो I just implemented it. So I just found it like is it better than using asynchronous programming or like
Celery does asynchronous programming.
So मतलब
Celery पे क्या है? You have task. You use a message broker, let's say Redis. The task gets submitted to Redis. Celery workers consume from Redis. Correct. So replace Redis with Kafka or Kinesis or SQS or RabbitMQ. Pick anyone. It's exactly the same. It is asynchronous.
Just a message queue at the end of the write.
Exactly. Yeah.
No, I mean to say at least we achieved मतलब कि ज़्यादा refactor नहीं करना पड़ा code, and we like achieved asynchronity in our code. So is it native to Python? Because utna मैंने
exactly. Celery is native to Python. Celery makes it easy for you to make things async because you would add a decorator called @task.
Correct. Yeah.
Right. You add that decorator, automatically your function becomes asynchronous function. It would register the function and the parameter whatever you're calling into Redis and being fetched. So it is basically the property of the library that it makes easier for any synchronous code to become asynchronous. Because all you have to do is just add the decorator and add a handler if needed.
And like just say we made multiple queues inside it. So like different functions were there. So we just made different multiple queues so that each of them goes into their separate queue and does not overlap with each other.
Yes.
Okay. Yeah, as in I was reading more around it.
बहुत अच्छा. Celery is very nice. But by the way, for folks who don't know, he's talking about Celery, CELERY. That's a Python specific asynchronous framework that makes it very easy for anyone to add to make code asynchronous. It's like basically Ruby ka sidekick. Basically Ruby ka sidekick. It is very similar to that. So, awesome. Tomorrow we'll be doing something fun. We'll be discussing about a distributed task scheduler, Dcron or Amazon CloudWatch event. So me and Ambrish were discussing it, and we came up with a very nice one. By the way, what we'll be doing is I'm not preparing slides for that. We'll just be doing brainstorming for the first one for the first 30 minutes. We'll be asking a lot of a lot of interesting questions. What would happen what would happen if that happens, so that like we understand the building blocks very well. How we actually make decisions when we are discussing things, like, so that would be the core part of it. And then we would be covering one topic around IR systems, right? About recommendation wala karte, otherwise I'll see ki how the gist is, and depending on that I'll be covering topics. ठीक है, तो कल का थोड़ा सा ओपन रखा है so that we cover like something interesting discussions like this, जैसे medium clap वाला ऐसे ही कर लिया अपन ने, right? Yeah, this one. So we'll just do something fancy around this. तो मजा आएगा उसमें. ठीक है. Meanwhile, do spend some time thinking about the designing ClickBus and other thing that I talked about. So some slides I'll upload. Please go to that. Please put some thought around it, and you'll see ki how by just having a basic foundational knowledge of this, you can design any system. Because if you are very clear with the building blocks, every system becomes like a piece of cake to design. Right? Chalo. Awesome. Thanks again, guys. See you guys tomorrow. Bye bye.
Thanks. Bye.